section title. Finally, Channels lets you showcase your other channels, your collaborators, or any other favorite channels. Next up is the Branding tab. With this tab, you can add various branding elements that can help make your channel visually unique and let viewers know what they can expect if they subscribe to your channel. First, you can add a profile picture. Your profile picture will appear wherever your channel is represented on YouTube, like next to your videos, comments, and in user search results. Next, you can add a channel banner image. This appears across the top of your channel and can give viewers a visual sense of your channel and content. Make sure to follow the image size requirements to get the best results. Finally, if you add a video watermark, it will appear on your videos in the bottom right-hand corner of the video player, and viewers can use it to subscribe to your channel. You can choose when it shows during your videos, at the end, at a custom start time, or throughout the entire video. Finally, there's the basic info tab. This tab lets you edit your channel name, add a channel description, add translations for your channel name and description in other languages, add links to sites you want to share with your viewers, and add contact information in case you want people to email you with business inquiries. Once you make changes to any of these tabs, click Publish to make your changes live on your channel. For more info about how to use YouTube Studio, check out this playlist. Thanks for watching.
Hey creators, let's talk about Creator Music, which helps you find and use mainstream music in your videos while still being able to monetize. We'll walk you through what Creator Music is and how it works. Let's dive in. With Creator Music, you can use high-quality music, even if it's copyrighted, without the risk of losing monetization on your video. Creators in the YouTube Partner Program can browse and access music for use in their content from a growing catalog of tracks, all within YouTube Studio. To get to the catalog, go to Studio, then Creator Music. On the homepage, you can browse tracks in featured collections, or by moods, genres, and more. If you have a specific track or artist in mind, you can use the search box on the homepage, or on the Browse tab. Here, you can filter by genre, mood, vocals, BPM, duration, and price. You can also sort your results by best match, newest, or price. When browsing or searching, you can preview a song by playing and scrubbing through it. Once you find a song you like, you can save it to your library by clicking the heart icon. The Your Library tab lets you see your saved, downloaded, and licensed tracks. You'll also see icons that represent the different usage terms that songs have within Creator Music. You'll see whether you can buy a license up front or share revenue with the artist or rights holder. We'll also show when a track is not available for licensing or revenue sharing, and instead would have visibility or monetization restrictions on your video if you use it. When you purchase an upfront license, you'll have the rights to use that song in your video without impacting monetization. As the copyright owners, music partners, like labels and publishers, set the pricing for the tracks they offer for licensing. The price of a license can be subject to change at the discretion of the rights holder, but any pricing changes won't affect your past license purchases and usage. Some tracks have a set price for all creators, some are free, and others may have pricing based on a channel's size. If you click the price, you'll be able to view license details like pricing information, supported regions, expiration information, and monetization policy. Other songs in Creator Music are available for creator revenue sharing, meaning you'll split a portion of the video's revenue with the song's rights holders. For some tracks, the option to share revenue may depend on how much of the song you use, so be sure to review the usage terms by clicking on the revenue share icon. Lastly, you may see that some songs are not eligible for upfront licensing or creator revenue sharing. For these tracks, you'll see an icon that indicates whether using the song will result in loss of monetization on your video, or if the video will be blocked in one or more countries. We're constantly expanding the catalog, so check back periodically to see what new tracks are available. To purchase a license from Creator Music, click on the price listed in the catalog to begin the checkout process. After reviewing the terms, click Buy License. Enter your payment info and click Pay Now. Once the license has been purchased, you can download the song and add it to your video while editing. When you're ready to upload your video, you'll simply add the license during the upload flow on the Video Elements page. You can do this by clicking Add.
Il mio cappello è pieno di slim, nel bosco fitto e
From here,
misterioso.
you'll see a list of the licenses you've purchased, where you can click Add next to the song you used. You'll get a confirmation once the license has been added. Then, you can review the copyright details of your video. To finish the upload process, click Return to Upload, where you'll see a green check mark that everything is all set. If you use a song in your video but didn't buy a license already, you'll also have the option to purchase one that you previously downloaded or saved from the video owner's page. Similarly, if you forgot to add a license to your video and a match is found during the check step of the upload flow, you can add or purchase a license if you want to. And finally, a few things to keep in mind. The licenses you require through Creator Music are only valid on YouTube. Creator Music licenses are valid for use in a single video. Buying a license means you have the permission to use the music according to the license terms and conditions, and does not mean you own the music. Licenses are unique to your channel, so you can't transfer them to anyone else. You don't need to purchase licenses for shorts. Instead, you can use the shorts audio feature. Revenue sharing does not impact the revenue you receive from fan funding features like Super Thanks, Super Chat, and channel memberships. Revenue sharing for certain songs can vary by country. It depends on operators, rights holders, and who share it. And when you share revenue on a video, it's not the same as getting a license to use their content. So, your video can still be subject to changes in policy or other actions from a rights holder like a music label or publisher at any time. We hope Creator Music helps you tap into a wider range of music that's in sync with your creative beat and content budget. We plan to continue expanding our catalog and licensing options in the future. For more info, check out the links in the description. Thanks for watching.
Round 1.
Live streaming on YouTube is a great way to connect with your audience in real time. Whether you're streaming an event, teaching a class, playing video games, performing for your fans, or hosting a Q&A, YouTube has all of the tools that will help you manage your stream and engage with your community in real time with live chat. There are 3 ways you can live stream on YouTube: with a mobile device, a webcam, or with an encoder. Webcam and mobile are great options for beginners and allow you to go live quickly without much setup, while encoder streaming is ideal for more advanced and customized live streams. Here's a quick overview of each one. Mobile streaming. You can stream from the YouTube app with a mobile device. To live stream on mobile, you'll need at least 1,000 subscribers and a phone or tablet with a camera. This is a great option if you're looking to be flexible with where you stream and capture moments or events on the go. Webcam streaming. Anyone with a YouTube channel can easily live stream using webcam and your computer. Streaming this way doesn't require extra software, and since most computers have built-in cameras, this option requires no extra equipment. Webcam streaming is great for hosting live Q&As with your fans or just hanging out with them. Encoder streaming. Encoders allow you to capture content, including your desktop, camera, microphone, and more, and send it out to YouTube Live to be streamed to your audience. This type of stream is commonly used for gaming, sporting events, concerts, or conferences. So this is a good option if you want to live stream gameplay, overlays, or use special hardware, preamps, mics, and cameras. Hopefully this overview helps you choose the best option for yourself, depending on the type of content you want to stream. With any of these options, make sure to plan and test out your sound and visuals beforehand with an unlisted or private stream. This will also help you feel more comfortable with the look and sound of your stream. Once you're ready, be sure to let your audience know you plan on going live. And of course, keep in mind that all of the content you're streaming must adhere to
Trallalero, trallalero, tralala, porco Dio e porco Allah.
Now, if it's your very first time streaming, there are some things you'll need to do before you can start. First, you'll need to verify your channel. Before you can stream, make sure you verify at youtube.com/verify if you haven't already. Note that this verification is different than the verification badges you might see on some channels across YouTube, and it just requires a simple telephone number verification. Then, you'll need to enable your channel for live streaming. To do this, go to youtube.com while signed in. In the top right corner, click the create icon, and then click go live. And if it is your first time going live, you'll see a prompt saying that YouTube is verifying your account for live streaming access. This process can take up to 24 hours, so once again, make sure you're planning ahead. And once 24 hours have passed, you'll become enabled to start live streaming. Once you're all set up, you can choose how you want to go live on YouTube. For deep dive information on the 3 different streaming options, and more videos on how to create and manage live streams, watch this playlist. And check out the Help Center articles linked in the description down below. Thanks for watching.
Let's talk about uploading podcasts from an RSS feed to YouTube. If you're an audio-first podcast creator, you can submit your podcast RSS feed to YouTube, which will upload your podcast episodes to YouTube and YouTube Music. Let's walk through what RSS feeds are, how they work with YouTube, and how to submit them in YouTube Studio. First, why do podcasters use RSS feeds? Many podcasters use an RSS feed to distribute their podcasts across different platforms. Setting up an RSS feed is something that can be done outside of YouTube using third-party platforms. When you upload a podcast episode to your RSS feed, it will automatically be made available on all the podcast platforms your feed is connected to. This means you only need to upload an episode once, and it will be distributed to multiple places. Next, how do RSS feeds work with YouTube? When you submit your RSS feed to YouTube, a static image video will be created for podcast episodes on your RSS feed. YouTube will use your podcast episode or show art to create the static image video. When a new episode is added to your RSS feed, YouTube will automatically upload the static image video to your channel on your behalf and notify your eligible subscribers. Your podcast and its episodes will then be available on YouTube and YouTube Music. There's no subscriber requirement to use the RSS upload tool, but you'll need to have access to advanced features. You can check if you have access to advanced features by going to YouTube Studio, then Settings, then Channel, then Feature Eligibility. Now, let's walk through how to submit a podcast RSS feed to YouTube. First, head to YouTube Studio and hit Create, then New Podcast. Choose Submit RSS Feed. Next, you'll need to review the terms of service. If you agree to the terms, click Accept. At the next step, you'll need to enter your RSS feed URL, then click Next. Here, you'll need to verify ownership of the RSS feed by entering the code sent to the email address you use on your RSS feed. Enter the code, then click Verify. This will lead you to the upload step. Here, you can choose to upload old episodes from your RSS feed. You can choose to upload all episodes in your feed, choose to upload episodes published since a certain date, or choose to not upload any old episodes. Note that if you choose to upload old episodes from the RSS feed during this setup phase, they'll be uploaded as private initially, and your channel subscribers won't receive notifications for them. They will only receive notifications once your podcast is published on YouTube and new episodes are uploaded from your RSS feed. At the upload step, you'll also have the option to set a default paid promotion setting for your episodes. To comply with YouTube's terms of service, podcast content that you upload to YouTube cannot contain advertisements, but your podcast can include paid promotions like host-read promotions, sponsorships, or endorsements. You're just required to let us know. You can click the checkbox to set it as a default for any episode uploaded from your RSS feed. You can also change this later at the podcast or video level in Studio. Note that we'll let viewers know that the video contains a paid promotion when this setting is checked. Once you've made your selections, click Next. Finally, you'll reach the visibility step. At this point, you can click Save to finish your RSS feed setup. Remember, your past episodes will be uploaded as private videos, and you'll still need to publish your podcast, so nothing will be made public by clicking Save and finishing setup. You can click View Podcast to go to the Podcast tab. From here, you'll need to publish your podcast. Note that once you've created your podcast from the RSS feed, it can take some time to upload the selected episodes. You'll see how many episodes are left to upload. We recommend waiting until all the episodes are uploaded and copyright checks are finished before publishing. Once you've confirmed there aren't any copyright issues for the episodes that were uploaded, you can click the Publish button next to your podcast. Remember, Your subscribers won't receive any notifications at this point, only when you upload new episodes moving forward. Now let's walk through editing your podcast once it's published. If you want to edit your podcast show details, hover over it in the podcast tab and click the pencil icon. You can edit things like title, description, and thumbnail. You can also disconnect the RSS feed and change the default visibility of new uploads from the feed. For individual episodes, keep in mind that YouTube will sync changes you make from the RSS feed to YouTube, including an episode's title, description, and release date. If you want to edit the details of an individual episode to be YouTube specific, you can still edit any of these fields directly, just like any other video. To do this, click into your episode and you can make edits from the details page. You can always choose to revert back to the RSS value if you change your mind. To do this, click the three-dot menu, then View Sync Status. Under Status, click Revert to RSS. If you already have podcasts on YouTube, you can also connect your existing podcast to an RSS feed. Under Podcasts on the Content tab, find the podcast you want to edit and click the pencil icon, which will lead you to the details page. Under RSS settings, click Connect to RSS feed and follow the prompts. To avoid uploading duplicate episodes, we recommend setting the upload date to after the last published episode in your RSS feed. Finally, let's walk through some things to keep in mind when it comes to using an RSS feed to upload your podcast to YouTube. Note that YouTube won't distribute your podcast to other platforms. Although YouTube will automatically sync changes made to your episode details, we won't automatically update show detail changes made from your RSS feed. If you want to edit these details on YouTube, you can do so on the podcast details page. YouTube will also not automatically update audio files that are re-uploaded to your RSS feed. If you want to update the audio for an episode, from the video details page, click the three-dot menu, then Re-upload from RSS feed. For more information on submitting a podcast RSS feed to YouTube, check out the links in the description. Thanks for watching!
The YouTube Studio mobile app lets you manage your YouTube channel on the go so you can stay connected and productive from anywhere. In this video, we'll show you how to use the Studio app to check out your latest stats, update video details, respond to comments, and more. This app is separate from the YouTube main app that's used to watch videos and is designed specifically for creators. To use the app, you can download it from Google Play on Android or in the App Store on iOS. Once you have the YouTube Studio mobile app installed, sign in. You'll first see your dashboard. Here, you'll get a quick overview of your subscriber count, some high-level analytics for your channel, and insights for your latest video performance. You'll also see your recent uploads, recent comments, and any known YouTube issues. The dashboard gives you a snapshot of the latest on your channel. From here, you can choose to deep dive into any of these sections by tapping the box or tapping View More. At the top of your dashboard, you'll also see the menu icon, notifications, and your account icon. The menu icon pulls up the other pages you can explore in YouTube Studio, like your videos, playlists, comments, and analytics. On the videos page, you'll find a list of all your videos and past live streams. You can filter by video visibility, or search for a specific video or stream. You can also sort your list by most recent or most viewed. Tap into one of your videos to see a quick snapshot of the video's performance and comments. You can also share the video, or tap the pencil icon to edit its thumbnail, title, description, visibility, and other settings. things.
Las vaquitas
You'll see all
saturnitas
of your
dicen,
playlists on
mitas
the playlist
dicen,
page.
mo, mo.
Here,
Los
you can tap into
rulitos
a
dicen,
playlist
bla,
to
bla,
see
bla,
what
bla,
videos
bla,
are
bla,
in it,
bla,
along with its
bla.
visibility and
Los
number of playlist
chimpancinitos
views.
dicen, para
From here, you can share a
Los
playlist or watch it on
capuchinitos
YouTube.
dicen, asesini,
Tap the pencil icon to edit the
Los
playlist title,
crocodilitos
description,
dicen, cabum, hacen
visibility,
cabum,
and
cabum,
ordering,
bum.
or
Los
to delete the
libritos dicen, la, di, la, di,
The
la.
comments page lets you see recent
Las
comments on your videos.
capuchinitas dicen,
You can filter by comments that are published,
Las
held for review, or likely to be spammed.
tralalili.
Publish
Las
comments, interact with them,
dicen,
reply, or tap the menu icon to remove or report the comment, or hide the user from your channel.
Los tun tun
You sort by
tuncitos
comments held for
dicen,
review,
tun
or
tun
comments
tun
that are
sahur.
likely spam. You can approve, delete this comment, flag, or hide the user from your channel. The analytics page lets you deep dive into your channel and video data like real-time views, watch time, impressions and CTR, traffic sources, and more. Tap into a card to view data for different date ranges. You'll see two other icons across all pages at the top of your YouTube Studio mobile app. Notifications and your account icon. The notifications icon leads you to any alerts you might have for your channel and videos. Studio mobile notifications notify you when you see notable subscriber growth or get comments. When you tap the gear icon, you can choose to enable or disable notifications, and customize your notification preferences to get only the notifications you want. You can also clear all your notifications by tapping here, or clear individual notifications by swiping. Finally, your account icon lets you switch accounts, manage your app settings, send feedback, get help, or go to the YouTube main page. On Android, you can also turn on dark mode here. For iOS, you need to turn on dark mode from your phone settings. Check out more videos about YouTube Studio here, and check out the Help Center articles linked below. Thanks for watching.
Hey there, I'm Mosh and welcome to Python Projects for Beginners. In this course, we're not just going to build some cool Python projects, we're going to dive deep into the process of thinking like a programmer. Coding isn't just about getting things to work, it's about understanding the problem, breaking it down, and building solutions that are clean, maintainable, and actually make sense. Most courses will show you how to write code, but they don't teach you why you're writing it that way. Here, I will walk you through my entire problem-solving process from the initial idea to the final polished solution. By the end of this course, you won't have just cool projects under your belt, you'll have the skills to tackle coding challenges with confidence and write code that you can be proud of. So if you're ready to go beyond just coding and start thinking like a problem solver, let's dive into Python Projects for Beginners. Now, before we jump into projects, I want to quickly talk about what you'll need to know to get the most out of this course. You don't need to be a Python expert to follow along, just a basic familiarity with Python is all that's required. If you know how to work with variables, loops, functions, and maybe a little bit of file handling, you're all set. As we go through the projects, I'll be using some more advanced Python features here and there, but don't worry, I'll explain those concepts thoroughly as we encounter them. If you feel like you need a little refresher or you want to dive deeper into Python, I'll let you cover. You can check out my Python tutorial on YouTube, where I'll walk you through the basics in a clear and easy to understand way. And if you're looking to really master Python, I'll put a full course on my website that takes you from the basics to advanced concepts. The links are below this video.
Chimpanzini, bananini, bananuchi, monkey, gucci, chimpanzini, cuckoo,
Now, I want to quickly go over some of the materials that come with this course. First, we have the project pattern. This is a PDF that outlines all the projects we're going to work on together. For each project, I've included additional challenges for those of you who want to push yourselves further. Next, all the code we write in this course is available on GitHub. This is where you can find the complete source code for each project. Whether you want to compare your solution with mine or just grab the code to experiment with, it's all there. You'll find the links to both the project handbook and the GitHub repository right below this video. Alright, that out of the way, let's move on to the next lesson. Before we dive into the project, I want to take a moment to talk about how I've structured this course and how you can get the most out of it. I've designed this course to be hands-on and practical. For each project, I've started to show you the project and at this point, I encourage you to pause and try to work on this solution on your own. This is where the real learning happens, by thinking through the problem and applying what you have learned so far. Once you have given it a shot, come back and watch how I break down the problem into manageable steps and start coding the solution. Your code may be different, and that's totally fine. I don't expect your solution to be exactly like mine. We all think differently. Use my solution and code as inspiration to see if there are better ways to write code. For the first few projects, if you feel like you are not quite ready to start and finish a project on your own, just watch my solution and code along with it. Then, once you have a bit more confidence, tackle the other projects on your own, and then come back to see my solution for ideas to improve your code. Look, I've been coding for 25 years, and I still encounter challenges depending on the projects I'm working on. So if you find some of these projects difficult, don't be discouraged. That's part of your learning journey. The things that feel complex today will eventually become simple, and you'll be ready to take on new challenges. Remember, this course isn't about quick wins. It's about building a strong foundation in problem solving that will serve you throughout your career. By the end of each project, you will not only have a working solution, but also a deep understanding of the logic and thought process behind it. Now let's get started. Alright, for our first project, we're going to build a dice rolling game. So let me show you what happens when we execute this program. First, we get this question, roll the dice. Here we have only two options, yes or no. If we type anything else, we get an error message saying invalid choice. Now we can type a Y, either lowercase or uppercase, it doesn't matter. And every time we get two new random numbers, just like how we roll a dice. Now if you type N, our program terminates and displays a message saying thanks for playing. Now I want you to spend 10 to 20 minutes on this project and then come back and see my solution.
Las capuchinitas dicen capuchina.
Before we jump into coding, I always take a moment to map out what I want to do. Kind of like checking a map before we start a road trip. It helps me see the big picture and avoid getting lost along the way. So let's quickly plan our approach before we start writing any code. Trust me, it makes things much smoother. So in this Python file, I'm going to use comments to map out how this program should behave. So first, we should ask the user a question, like roll the dice. Then we should check the user input. So if user enters Y, then we should generate two random numbers and print them. Otherwise, if the user enters no, then we should print a thank you message and terminate the program. Otherwise, if the user types anything else, we want to print an error message like invalid choice. Now, we want to make sure that the user can play until they decide to so we should put these instructions inside or repetition. So everything here should go inside okay, now let's work on turning these comments into action. So first we will ask the user to roll the dice, and to do that we use the input function. Here we should type prompt, we can use double quotes or single quotes, different people have different preferences. Whatever you like, just make sure to stick to that. So here I'm going to ask roll the dice and give the options yes or no. We add a colon followed by a white space, so whatever the user types will be separate from
Tralalero tralala did it.
now we store the result in a variable called choice. Next we should check choice equals 1. So if choice equals a lowercase y or choice equals an uppercase y. That's one way to do this. There's a smart way. You can treat whatever type as lowercase. So look, if you hover our mouse over this choice variable, we get the type is a string. So the input function returns a string, and you know that in Python, string objects have a bunch of methods. So here we can use the lower method to convert whatever the user types into lowercase. With that, we can get rid of the second condition. Okay, now we should generate two random numbers. And to do that, first we have to import the random module. Now in this module we have a method called random.rand to generate a random integer or a random number between these two numbers, a and b. In this case, 1 and 6. Now this returns a random number, so we store it in a variable like die1. Now we have to repeat this to generate the second random number. Next we should print these numbers. So here we call print. Now for simplicity we can use a formatted or an F string. So type an F before our quote, and here we add parentheses. Inside the parentheses we want to print our random numbers like 1 and 2. But instead of hard coding these numbers, we want to print the actual random numbers that are generated here. So we replace 1 with curly braces to add a placeholder for a hole in our string, and inside this hole we add die1. And similarly, replace 2 with curly braces and add die2. So we print these numbers. Next we should check if the user types an N. So elif choice equals N, then we print a thank you message. So thanks for playing. Now to terminate the program, we want to click out of our loop. Now we haven't added the loop here, so on the top. Now there are two ways to do this. Some people like to declare a variable like running or playing and initialize it to true. Then they add it as the loop condition. So while playing is true, then we're going to repeat these instructions, and when the user types an N, we can use the break statement to jump out of this loop. It's one way, but there is a better way. This variable here is really unnecessary, so we can use true as the condition for this loop and get rid of one extra line of code. Also note that it's a good practice to add a line break between our import statements and the rest of the code. It makes our code cleaner and easier to write. So we're almost there. Finally, if the user types anything else, we want to print a message. So print
Round 3.
invalid choice.
Fight.
As simple as that. That was our first project. Depending on your programming skills, this might be too easy for you, but don't worry. As we go through this course, our projects will gradually get more complex. Now, if you want to challenge yourself, look at the workbook that I gave you at the beginning of the course. After each project, there are ideas for enhancing the program and challenging yourself. Alright, for our next project, we're going to build a number guessing game. So here's how it's going to work. When we run our program, it generates a random number between 1 and 100 every time. Yes. Then if you type an invalid number like A, we get an error message. So let's type a valid number like 50. Now the program is giving us feedback. It says this is too high. So let's try 25. It's still too high. What if we try 10? Still too high. How about 5? Now it's too low. So the number that the computer has generated is between 5 and 10. Let's try 7. It's too low. Let's try 8. There you go. Guess the number. So we spend 15 to 20 minutes on this project and then come back and see my solution.
Round 4. Fight.
Alright, once again, before we write any code, let's map out what exactly we're gonna do. So first, we should have our program generate
Patapim, il mio cappello è pieno di slim, nel bosco fitto e misterioso.
To make this number that the user entered is higher than
Patapim, patapim.
that means let's store this in a variable called number2guess. Always use descriptive names for your variables. So don't use variable names like n or x or a, because someone else reading your code, they have no clue what these variables represent. Okay? So number2guess. Next, we should ask the user to make a guess. So I don't want to add the loop yet. Let's just convert this comment into code. So here we call the input function and tell the user to guess the number between 1 and 100. Now you know that the input function returns a string, so we can store it in a variable like user input. Now we should convert this to a number, and to do that we use the int function. It has user input and store the result in a variable called guess. Now look, user input is only used in a single place. There is no need for this variable anywhere else in this program, because for the rest of our program we're going to work with this integer. So we can simplify our code and make it more concise by removing this variable. It's unnecessary. So we can get the string that is returned from the input function and pass it directly to the int function. With this we can remove this unnecessary variable. So when this program is executed, first the input function is called, then the return value, which is a string, is passed. Now how can we validate that this is a valid number? Well, before we do that, let's just print guess on the terminal to see if our program works up to this point. So this is a good technique for building larger programs. Always do it in baby steps. So instead of implementing the entire program, do it in baby steps, make sure it works, and then move on. So here in the terminal, let's run our program and enter an invalid number, like 8. Right, look, our program crashed because an exception is thrown on this line. And here's the type of the exception, value error. So to handle this situation and prevent our program from crashing, we have to add this line inside a try block. So we type try, then add indentation. Then right after try, we should type except, followed by the type of error we want to handle. In this case, value error. Okay. Now if we end up here, we want to print an error message and say, please enter a valid number. Okay. Let's run our program one more time. So I type A. Okay, this time our program didn't crash, instead we got a friendly error message. Beautiful. So we're done with this step. Now we should give the user some feedback. So after the except block, I want to add a line break to separate this bit of logic from the rest of the logic, which is about giving the user some feedback. So using these line breaks is like how we break up a story into multiple paragraphs. Imagine if you read a book and there are no paragraphs. Obviously reading that book is very difficult. So here we can check if guess is less than number to guess.
Las vaquitas saturnitas dicen
too low. Now here we have an error message on the guess variable saying guess is possibly on down. Again, this is a weird error message. Basically this is happening because this variable inside the try block. So it's only meaningful inside the try block. This is called the so-called variable. So this error we have to move these two lines inside our try block and add indentation. So we read a number, then we check is less than the number less. Otherwise, else guess is greater than the number yes.
Las capuchinitas dicen capuchina, capuchina.
So here we can say congratulations.
Las tralaleritas dicen tralali.
Now let's get rid of these comments. We don't need them anymore. Now we want to put all these instructions inside an infinite loop. So here we type while true and move all these lines inside our loop. Now after congratulating the user, we should use a break statement to break out of this loop. Okay? Now let's run our program and see what happens. So first we enter an invalid number. Okay, we got an error message, so we can try again. Let's type B this time. Beautiful. Now let's type a number like 50. It's too high. Let's try 25. It's too low. So let's try 40. Too low. What about 45? Too high. So it's between 40 and 45. Let's try 43. It's too low. It has to be 44. Okay, our program terminated. Our next project is a fun game that we have all played in our childhood, rock, paper, scissors game. Now this project is a little bit more challenging than the previous project, so let me run the program and show you how it works. First we get a question, rock, paper or scissors. Here we only have three choices, R, P or S. If you type anything else, you get an error message saying invalid choice. Now let me go with R, that is short for rock. So I chose rock, computer chose paper, and I lost. Now right after we get asked if you want to continue. Let's try again. This time I'm going to go with scissors. So I chose scissors, computer chose paper, I won. Now I don't want to continue, so let's type N, the game ends. Again, this project is a bit more challenging than the previous ones, so spend about 20 to 30 minutes on this, and then come back and see my solution.
Trallalero, tralala, bombardiro, crocodilo.
Alright, once again, before we write any code, let's map out what we're gonna do. So first, we're gonna ask the user to make a choice. Now, if the choice is not valid, we're gonna print otherwise, we should let the computer make a choice as well. Next, we should print the choices using emojis, and this is the fun part. Next, we should determine the winner, and finally we ask the user if they want to continue. If not, we're going to terminate. So this is the structure of our program. Now let's start coding. So first we should ask the user to make a choice. To do that, we use the input function. Here we type rock, paper, or scissors. And in parentheses we can type the valid options, so R, P, and S. Now we get the result and store it in a variable called user choice. Next we should validate the choice. So just like before, here we're going to call the lower method, so we can treat the user's input as lowercase text. We talked about this technique in one of our earlier projects. Now to validate the user's choice, here we can use a bunch of if statements. So we can say if user choice does not equal R and user choice does not equal P and user choice does not equal S, then we can print an error message and say invalid choice. That's one way, but this is not a very clever or very professional way to implement this. There is a better way. We can store the list of valid choices in a list and then check to see if the user's choice is in that list or not. So, in the first line, we can declare a variable called choices and initialize it to a list of valid choices. Now we can simplify this statement and say user choice not in choices, then print an error message. This implementation is more concise and more elegant. Now we can further improve this and convert this list to a tuple. Why? Because lists can be modified in our program. So somewhere you might accidentally modify the list and use the append method to add a new item to the list, or remove method to remove one of the existing items. This could be an accidental mistake. But if you convert this to a tuple, it becomes read-only. So tuples, look, they don't have the remove or append methods. So tuple is just like a read-only list. Okay? So we have our valid choices, and we're done with this step. Now, before going further, let's test our program. So I'm going to remove these two lines. Now back to the terminal, let's run our program. So if you type A, you get an error message, beautiful, but if you type R,
Los
we don't get an error.
trulifulitos dicen bla bla,
Next, we
dicen
should
bla
let the
bla
computer
bla
to
bla
make a
bla bla
choice.
bla.
And to
Los
do that, first we have to
chimpancicitos
import
dicen pananiri,
the random
pananiri,
module.
pananiri. Los
Now,
orcaleritos
earlier we used the random method to generate a random number between two numbers. But here we want to use a different method, and that means choice. With this, we can pass a list or a tuple like choices, and let the computer choose one of these valid choices. So let's store the result in a separate variable like computer choice. So we're done with this step. Now let's print the choices. So first I want to print choices without emojis just to make sure that my program is broken down. So here we can type you chose and then use concatenation to append user's choice here. That's one way, but a better and more elegant way is to use a formatted string. So we prefix the string with an F, which is short for formatted, and here we add curly braces to insert a value dynamic.
Boneka
In this case,
Ambalabu.
user choice.
Entitas jahat yang banyak meresahkan masyarakat akhir-akhir ini.
Okay. Similarly, structure called a dictionary. A dictionary is used to map a key to a value. So we can map the character R to the emoji of a rock. Similarly, we can map the letter S to scissors. Okay, now how can we declare a dictionary? Well, here we can declare a variable called emojis and set it to curly braces. Inside the braces, we type key value pairs. So our key is going to be R, then we type a colon and map it to the emoji of a rock. Note that in this case, both our key and value are strings, but this is not a requirement. So we can map a string to a number or an object, whatever we want to do. Now, similarly, let's map S to scissors.
Ready?
And also P to paper. Okay, now let's remove these comments. Back to the part about printing the user's choice. Instead of printing the user's choice, which is a letter like R, P, or S, we are going to go into this dictionary and look up the value associated with a given key. So here we type emojis, then using square brackets, we can look up the value associated with one of these keys. Now here in the auto completion box, we can see the valid keys, which are P, R, or S, but we're going to replace this with user choice. Now similarly, here we type emojis and ask computer choice. Let's run the program one more time. If I type R, I get rock and computer chose scissors. Alright, we're done with this step. The next step is determining the winner. Now, before moving forward, I want to add some line breaks to divide our code into different segments, just like the paragraphs of an article. So, on the top, we are declaring our emojis and valid choices. These two lines are highly related, so I want to keep them together. But look at the next line. The next line is about getting the user's input. This line has nothing to do with the previous line, so it's like a different paragraph in a story. So here we add a line break. Now again, These three lines are highly related because they are part of getting the user's input. So we want to keep them together, but separate them from getting the computer's choice. Now, once again, we add a line break here because this segment is all about printing the user's and computer's choice. Okay? Now, let's move on to the next segment, which is determining the winner. So we add a line break, and here we can check if user choice
Tung
is
tung
the same
tung
as
tung 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 sahur.
and we print tie. Another scenario where user choice is scissors and computer choice is again here we can print you win. There's a better way. We can combine these two statements into a single statement using the logic. So this is one scenario where user wins. As you can see, now we type left bracket is now surrounded by right after now here we should select now we select the entire expression, cut it, and put it right here. Now similarly we type another OR operator and add the third condition, and that is user choice equals key or paper and computer choice equals rock. So if any of these conditions is true, the user wins. Otherwise, the user loses. Okay? Now this line is getting a little bit too long. So to keep our code more readable, we can take it down to multiple lines. So right after the store operator, we add a line break. Now here we have an error saying expected expression. Because Python interpreter expects a colon here, so to tell the interpreter that this is a multi-line statement, here we add a backslash. Okay? Now to better format our code, it's better to line up all these conditions. So we put this on a new line, I tab, then on this line we add a backslash. Now these two conditions are perfectly aligned. Now similarly, let's add another backslash now, put this condition on a
dicen cappuccina, cappuccina, cappuccina.
Okay, we're good. So this is one way that you slow down multiple lines, but all these backslashes are kind of ugly. Let me show you a better way. Look, here we have three conditions, each surrounded by parentheses. Now we can grab all these three conditions and wrap them with parentheses like this. We can remove the backslash. Here we add parentheses. So the left one is here, and the right one should be at the end, right here. With this, we no longer need these backslashes anymore. So Python interpreter knows that this outer parenthesis represents a long expression. Okay? So we're almost there. We've determined the winner. Next, we shall ask the user if they want to continue. So once again, we add a line break to separate this segment from the previous segment, which is about determining the winner. And then use the input function to ask the user if they want to continue or not. So right away we call the lower method and then store the result in a variable like should continue. We cannot use the word continue because this is a reserved keyword in Python. Okay? So here we check if should continue equals n. Then we're going to terminate the program. Now, to do this, first we have to add these statements inside the while loop. So, here we add a while loop with true as the condition. Now, let's indent all these lines. So if the user types and then we're going to break out of this loop to terminate the program. Otherwise, if we type y or anything else, we can treat it as yes. So let's run our program. First, let's try an invalid choice, like A. Alright, our program crashed on this line 13, where we try to show the emoji associated with the user's choice. Now, obviously, in this dictionary of emojis, up here, we don't have a key with a value of 8, right? So, look, down here, you're validating the user's choice. If the user types an invalid choice, we just print an error message, but the rest of the code gets executed. So we end up on this line, and this line throws an exception. To fix this issue, right after printing an error, we should use the continue statement to jump back to the beginning of the while loop. So ask the user one more time to make a choice. Let's try one more time. If I type an A, we get an error message and our program doesn't crash. Beautiful. Let's try again B. Great. Now if I type R, I chose rock, the computer chose scissors, and I won. Beautiful. Now shall we continue? If I type yes, I get a chance to make another choice. Let's go with P. I chose paper, computer chose rock, so I won again. Great. Now if I type N, our program terminates.
Las conejitas dicen ambalabu, ambalabu. Los
Our program is working, but just because it's working, it doesn't mean our work is finished. We should always review our code and find opportunities to refine and improve it. In coding, this is called refactoring. It's basically a fancy term for changing the structure of our code without changing its functionality. In this lesson, we're going to look at a common refactoring technique called modularization. Modularizing code means breaking down a large program into smaller, reusable parts called modules or functions. Think of it like organizing a messy room into different boxes, each holding specific items. Instead of having one big pile of everything, we put related things together, make it easier to find what we need and keep things tidy. Now, the beginning of the while loop. Otherwise, we break out of this loop, and at the end, we should return a value from this function. What value? User's choice. So here we use the return statement to return user choice. Now there is a better way to write this code. Instead of breaking out of this loop, we can return user's choice right here. So return user choice. With this, we can make our function slightly shorter. Okay? Now let's show you what happens if we swap these if and else statements. So instead of checking if user choice is not in the list of choices, we check if user choice is in the list of choices. In this case, we're going to return everything, so return user choice. Otherwise, we're going to print an error message and continue. Okay. Now, with this implementation, we don't even need the continue keyword, because if we end up here, we print an error, and then the control automatically moves to the beginning of the while loop. So we can get rid of the continue statement and make our code slightly shorter.
Las capuchinitas dicen capuchina, china, capuchina.
Earlier we had a few lines for filling user's input. Those lines are now inside get user choice function. So here we call get user choice, get the result, and store it in a variable called user choice. Okay? Next, we're going to apply the same technique to these two lines. These two lines are highly related and have a single responsibility, displaying choices. So let's select these two lines.
Bombardiro,
Now,
crocodilo,
after this function, we define another function called display choices. Good. Now, back to our while loop. Right here, we call display choices. Okay. Next, we need to extract these few lines for determining the winner. Again, select cut. Let's define a new function. Determine winner. Now here we have an error because we need to add indentation here. Good. Now back to our while loop. After we display the choices, we call determine winner. Good. Now we can do the same thing with our while loop. So we can extract this entire logic and put it into a separate function. Let's call that play game. This is where we have our game logic. Let's select all this code and add indentation. Good. So here's the end result. Now if you look up here, we have a bunch of errors because in this function, display choices, we do not have a variable called user choice. This variable is declared inside our play game function. So to fix this issue, we have to pass user choice and computer choice to these functions. So we go to our display choices function and give it two parameters, user choice and computer choice. Now the errors are gone. Similarly, in determine winner, we add two parameters, user choice and computer choice. The errors are gone. Beautiful. Now when calling these functions, we should pass these values as arguments, user choice and computer choice. One more time, user choice and computer choice. Good. Now one last thing. If we run our program, nothing happens because after this refactoring, we move different lines of our code inside different functions, but currently none of these functions is getting called. So at the end, we have to call the play game function, so our program starts. Let's run it one more time. There you go. Let's enter an invalid choice. It's still working. Let's type R. Our program is working, and let's terminate it. So with this refactoring, we broke down our program into smaller, reusable functions. Each of these functions has only a few lines. So if there is a bug in one of these functions, we can only focus on those few lines. This is easier than reading and understanding an entire script. This is the benefit of modularizing code.
Trallalero, tralala, bombardiro, crocodilo, scimpanzini, bananini,
We have one more opportunity for improving this code. Look, there are multiple places where we have defined our choices. This is bad for two reasons. One reason is that if we have a typo in the code, our program is not going to work. That's number one problem. The second problem is that if tomorrow we decide to change our choices from R, S, and P to something else like 1, 2, and 3, there are multiple places that we have to modify. In programming, we have this principle called drive, which is short for don't repeat yourself. So we don't want to have repetition or duplication in our code. Most of the time, it's a bad practice. So how can we solve this problem? Well, we can generate this tuple based on this dictionary. In this dictionary, we have three key value pairs. Our keys are R, S, and P. So let me show you how we can convert this dictionary to a tuple with these values. First, I'm going to select this line and the rest of the code. Now, you can convert all these lines to a comment by pressing Command and slash on Mac or Control and slash on Windows. Now, all these lines are commented out, so they're not going to get executed. We only have the declaration of our dictionary. Now, let's print emojis dot. Look, here we have a method called keys, which returns the keys of this dictionary using this structure. Let me show you. So back to the terminal, let's run our program. Right, here's what we have. We get a magic type div keys or dictionary keys, and then we have but this is not exactly what we want. What we want is a tuple. But this is very easy to fix. We can pass the object that is returned from this method And with this, we get a tuple exactly like the tuple that we So we can set choices to tuple emojis. This technique now let's pull back all the code here. So one more time, command /back or Now there are other places where we have multiple choices. Then if we have a typo, our program does not work. So realistically, we need a single place for defining our choices. To do that, we can go to the top and declare a bunch of constants. By convention, we use uppercase letters to declare constants. So we can declare a constant like rock and set it to R. Similarly, scissors and now anywhere we have R, S, and E, we replace them with constants. So I've selected R here. Now to select the next occurrence of R in this code, you press Command and D on Mac or Control and D on Windows. This instance is also selected. One more time we press Command and D. There you go. Now we have 3 cursors, all of them select R. So we can replace them all with raw in one. Now to cancel multi-cursor editing, press the skip button twice. We're going to select S.
Tralalero tralala did it.
Command and D twice to select these 2 instances as well. And replace this with scissors. Again, we press the skip button twice. Done. And the last one. Now, we have a single place where we have defined our choices, so no chance for typos, and if we decide to change the choices from R, S, and P to something else in the future, there is a single place we have to update. We can change this to 1, 2, and 3, and everything will work, okay? But there is another benefit here. Look down here where we determine the winner, our code is more descriptive. So instead of comparing user choice and computer choice with R and S, we can clearly see that if the user has a rock and the computer has scissors, the user is the winner. Hey there, I hope you've been enjoying this video so far. If you're finding this helpful and want to take your Python skills even further, I've got something really exciting for you. This video is just a taste of what you will find in my full course, Python Projects for Beginners. In the full course, we dive deep into more projects covering a wide range of concepts that will help you sharpen your problem-solving skills and become a confident Python programmer. If you're ready to level up, check out the link below to get access to the full course. I would love to see you there and help you on your Python journey. For our next project, we're going to build a QR code generator. So first we enter some text or URL. I'm going to enter the address of my website, codewithmosh.com. Next we enter a file name. Let's enter mosh.jpg. Now we have a QR code saved in this file. This file is right here. So this is the QR code for my website. If you scan this with your phone, it will open your browser and take you to my website. Now to build this, we're going to use a third-party library called QR code. So head over to pypy.org/project/QR code. Read the documentation for this library. The purpose of this project is to get you familiar with using third-party libraries. So this project doesn't have really complex logic, only third-party packages. So it's for a few minutes to go through the documentation, then install this library and build this project. The first thing we're going to do is set up a virtual environment. A virtual environment in Python is like a separate, isolated workspace on your computer where you can install packages and run Python projects. Think of it as a clean, organized room that is separate from the rest of your house. In this room, you have the
Trallalero tralala, porco Dio e porco Allah.
Tralala, 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 tralala.
Tralala, tralala, boom boom go lilo, wado, watermelon, lilo, tung 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 sahur, tung 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 sahur, chimpanzini,
So to
bananini,
set up a virtual
bananini,
environment,
wow,
here
wow.
open the terminal window and type Python if you're on Windows or Python 3 if you're on Mac. Then we type -m, that is short for module. We're going to run this module venv. That's one of the built-in modules in Python for creating virtual environments. And then we specify a name for our virtual environment. By convention, we often use venv as well. Okay. Now VS Code is saying we noticed a new virtual environment has been created. Do you want to select it for the workspace folder? For now, select no. We'll come back to this later. Now take a look at the project directory. We have this new folder here, venv. And inside this we have a bunch of folders like bin, include, and lib. Inside the bin folder we have executables like pip, pip3, python, python, and so on. Now if you're a bit more experienced and are familiar with Git, you can see that we have over 1,000 files ready to be committed to our repository. We don't want to include these files in our repository. So to exclude them, here's the root of our project. We add a new file called .git-ignore. In this file, we add the files and folders we want to exclude from our Git repository. In this case, venv folder. So we add a /. Okay. Now, if you're not familiar with Git, don't worry about it. Just ignore this step for now. Okay? So we have created a virtual environment, but currently it's not active. So we go back to the terminal. To activate it, if you're on Windows, you type venv/script/activate. If you're on Mac, you type source venv/bin/activate. Okay. Now look, this virtual environment is activated. So any packages that we install will be installed in this virtual environment or in this isolated workspace. When we are done with this project, we can deactivate this virtual environment by
Sahur.
generator. So over here, you can call the strip method to get rid of any white spaces around our data. Okay? Similarly, I would like to strip any white spaces around the file name. Good. Now we are ready to generate our QR code. To do that, we go in the QR code module and create a QR code object. Here we want to set two parameters. One is box size. I'm going to set it to 10. These are just arbitrary values. I'm going to set border to 4. This returns a QR code object. We store it in this variable. Next we call QR.add data. Then we pass our data. Next we call QR.makeImage and set two arguments here. One is fill color, which I'm going to set to black. Again, these are arbitrary values. You can use any colors you want. We also set back color to white. This returns an image that we store in our variable. And finally, we call image.save to save it in this file. And at the end, we print QR code save as. Now here we want to add the file name, so let's convert this to a formatted string and insert file name here. Now let's run our program. So I'm going to enter the address of the website, in this folder, we have mosh.jpg. This is my QR code. So if you point your phone at this and scan it, this will open your browser and take you to my website. Hey there, I hope you've been enjoying this video so far. If you're finding this helpful and want to take your Python skills a little further, I've got something really exciting for you. This video is just a taste of what you will find in the full course Python projects for beginners. In the full course, we dive deep into more projects covering a wide range of concepts that will help you sharpen your problem-solving skills and become a confident Python programmer. If you're ready to level up, check out the link below to get access to the full course. I would love to see you there and help you on your Python journey. Welcome to Mastering JavaScript Unit Testing. In this comprehensive 4-hour course, I will take you on an exciting journey where we will explore everything you need to know about unit testing, from the very basics to more advanced techniques. If you're looking for a comprehensive, easy to follow, well-organized and practical course that takes you from zero to hero, this is the right JavaScript unit testing course. This course is packed with real-world examples and a ton of hands-on exercises, giving you plenty of opportunities to practice what you learn. By the end of this course, you'll have a strong foundation in unit testing. You'll be able to significantly reduce bugs and improve the overall quality of your code. This expertise will set you apart in the world of software development, opening doors to exciting opportunities and challenges. So, if you're ready to unlock the full potential of JavaScript unit testing and elevate your coding skills, join me in this exciting journey.
I'm Mosh Hamadani, a software engineer with over 20 years of experience, and I've taught millions how to code and become professional software engineers through my YouTube channel and online school, codewithmosh.com. If you're new here, make sure to subscribe as I upload new videos all the time. Now, let's jump in and get started.
Now, to take this course, you don't need any familiarity with unit testing at all. In fact, I've designed this course specifically for people who have never done unit testing because they find the idea intimidating. So I'm going to teach you everything from the ground up. But to take this course, you should have a basic understanding of modern JavaScript. That means you should be comfortable with concepts like importing and exporting, promises, async and await, and so on. If you need to brush up on any of these concepts, check out the JavaScript series on my website. So that's all about the prerequisites. Next, we're going to talk about the course structure.
Patapim, il mio cappello è pieno di slim.
Right, now let's
Nel
talk
bosco
about
fitto e
how our structure is
misterioso.
This course serves as the rock-solid foundation for unit testing and JavaScript applications. However, in order to dive this into, we won't be testing the front-end or back-end here because our primary focus is on nailing those fundamental unit testing concepts and best practices that often get overlooked in many other courses. This is where a lot of folks stumble when it comes to unit testing. They rush into testing React mode without grasping the essential foundations and best practices. So in this course, my goal is to equip you with a robust foundation. Once you have completed this course, you'll be well prepared to tackle my other courses. Here's a roadmap for this course. We'll kick things off by getting you familiar with the basics of unit testing. So in the first section, we'll cover what unit testing is, what are its benefits, and what are the common arguments against it. Then we'll see unit testing in action. You'll learn how to write basic tests and run them. Next up, we'll delve deeper into the core unit testing techniques and practices. We'll cover concepts like positive unit testing, ground unit testing, and closed testing, and so on. Then we'll explore how to use mocks, fakes, and isolate both unit tests. This is a very important technique used in unit testing. In the final section, we'll explore some handy static analysis tools like ESLint, Prettier, and TypeScript. These tools help you elevate the quality of your code and reduce the need for extensive test cases. Once you finish this course, you'll have a rock-solid foundation for testing JavaScript. If your goal is to write JavaScript libraries, you can take what you learned in this course and use it to test your libraries. If you're a front-end developer and want to learn how to test React applications, I've got you covered. I'm planning to create a dedicated course on the topic, and chances are, by the time you're watching this course, my React testing course is already published. As for backend testing, I've covered it in my Node course, so at this point, I'm not planning to create a separate course on the topic. Alright, now let's talk about how to make the most of this course. If you're brand new to unit testing, the best approach is to follow the lessons in order and complete the exercises along the way. It'll help you build a strong foundation. However, if you already have some experience, you might be tempted to jump around and focus on specific lessons. While that's an option, because the course is well structured, I would like to advise you against it. Why? Well, you might unknowingly have some bad habits or using less than optimal practices. As your instructor, I strongly recommend going through all the lessons sequentially. The fantastic part is that the course is concise and to the point, so you can easily complete it in a single day. Plus, it's full of practical examples and exercises, so you're not going to get bored with fluff content. Alright, now that we're on the same page, our next step is setting up our testing environment. Alright, let's talk about setting up our testing environment. First, head over to nodejs.org and download the latest version of Node. Now, in this course, just like my other courses, I'll be using Visual Studio Code or VS Code as my editor. You're welcome to use your preferred editor, but in this course, I'm going to show you a ton of shortcuts for increasing your productivity. So, while not necessary, I recommend you to download and install Visual Studio Code. Alright, before we move on to the next section, I want you to download the starter project I've created for this course. So head over to github.com/mosh-hamidani. Here go to repositories and search for JavaScript-testing. Here we have two repositories, the starter project and the finished project. The finished project contains the solution to all the exercises I've created for you. So let's start with the starter project. Then go to code, clone this URL, next open the terminal window and run git clone Good. So here we have this folder, JavaScript testing starter. Just open this with VS Code and you're good to go. Welcome back to another section of Unit Testing JavaScript course. This section is going to be your gateway to the world of unit testing. We'll kick things off by talking about what is unit testing, what are its benefits, and what are common arguments against it. Then we'll talk about different types of tests we encounter in real-world applications. Once we've got the theory covered, we'll talk about the tooling. We'll explore various testing frameworks out there. In this course, we'll be using VTest, which is a relatively new testing framework that has gained popularity. But the concepts you will learn in this course apply to other testing frameworks like Jest as well. So next we'll set up VTest and write our first unit tests. You'll see unit testing and its benefits in action. Then I will introduce you to the concept of test-driven development or TDD. We'll talk about the benefits as well as a few misconceptions about TDD. Next, I will show you various ways to run your tests efficiently. This is a key skill you need to have, especially when you deal with broken tests. You should be able to quickly filter your tests and focus on one or a few at a time. Now, every seasoned developer is expected to know how to navigate their code base quickly and smoothly. So I will show you various shortcuts in VS Code to navigate your tests and production code. Last but not least, we'll wrap up this section by talking about code coverage, which is a metric that shows how much of our code is tested. This is a great introduction to unit testing, so let's jump in and get started. So, what exactly is unit testing? Well, unit testing is a form of automated testing where we write code to check if our code works as expected. Here Here's an example. Imagine you have a function for calculating the monthly loan payment. Now, if you were to test this function manually, you would have to launch our application, possibly log in, navigate to a particular page, fill out a form, submit it, and then check if the result is calculated correctly. As we can see, this is pretty time-consuming. This is where automated testing comes to the rescue. We can write some code to directly call this function with various inputs and check if it returns the correct
TRALALERO
result.
TRALALA did it.
We execute this code using a program called a test runner, which displays test results in the console or terminal window. If the test passes, we see a green tick, otherwise we see a red cross. Using this technique, we can run hundreds or even thousands of tests in just a few seconds. Clearly, this is much faster than manual testing through the user interface. With automated testing, our code base consists of two types of code: the application code, also known as production code, and the test code or tests. Once we have a suite of tests, we can run them every time we make changes to our code, and this brings us a bunch of benefits. Firstly, unit tests help us identify and fix bugs early in the development process, long before they become nasty surprises in production. There have been many studies that show that the later we find and fix a bug in the development process, the costlier it is for the business. For example, fixing a bug after deploying the software can be up to 5 times more expensive than during the coding phase. Secondly, unit testing helps us refactor our code with confidence. Refactoring means changing the structure of our code without changing its behavior or functionality. For instance, we can extract a few lines of code and put them into a separate function. We're changing the structure of the code, but not its functionality. With unit tests, every time we refactor our code, we can run our tests to quickly confirm if our code still behaves as expected. Thirdly, writing unit tests encourages us to consider various edge cases and error conditions, and this leads to more robust and reliable code. And lastly, unit tests serve as documentation for how our functions should behave, and this makes it easier for others to understand and maintain a project. Now, despite these benefits, we have developers with very strong opinions, like our famous superstar developer, Mr. John Smith, who's skeptical about unit testing. He proudly claims that in his 20 years of software engineering, he's been writing bug-free code without ever writing a single unit test. On the other side of the spectrum, we have other developers like Test Smith, who are obsessed with writing tests and say every line of your code should be covered by tests. So who's right? Well, in my opinion, both of these viewpoints are extreme and can be costly for a business. Having no unit test at all and relying solely on manual testing can be very time-consuming, especially as our application grows in size and complexity. On the other hand, covering every line of code with tests can also be very expensive. We always have time and resource constraints. So next time you encounter one of these folks with strong opinions, don't get caught up in their debate. Instead, be pragmatic and find a good balance that works for your project. Keep in mind that every project is unique. New projects with rapidly evolving requirements might not be the best candidate for extensive unit testing, because as the requirements change, some of your tests may break and you end up spending more time fixing broken tests than delivering actual features. However, if your project is more established and certain features have stable requirements, it's a good idea to write a suite of tests to ensure that at least the critical modules continue to work as expected. This way, whenever you make changes to those modules, you can run your tests to get immediate feedback if you have broken something or not. In reality, unit testing is an investment in software quality. Like any investment, it can be fruitful or go wrong. If you skip writing tests entirely, you will rely solely on manual testing, and this will get increasingly costly over time. On the other hand, writing poor tests that produce inaccurate results and fail to give you real feedback about your code's reliability is a waste of time. So, just like how you should wisely invest your money, you should also use your time wisely when writing tests. You should write good tests that are maintainable, robust, and trustworthy. And that's what I'm going to teach you in this course. If If your tests are not maintainable, robust, and trustworthy, they offer no value. They get in the way and slow you down. It's better not to write them at all. Next, we're going to talk about different types of tests. In automated testing, we have three types of tests: unit tests, integration tests, and end-to-end tests. So what are the differences? Well, unit tests verify the correctness of individual units or components of an application in isolation. These units could be functions, classes, or even small modules. These tests are incredibly useful for catching bugs early in the development process. Integration tests focus on verifying how different units or components of your application work together as a whole. They help you identify issues that might arise when combining different units, such as data flow problems, communication between modules, and compatibility issues between components. End-to-end tests are the broadest type of tests, focusing on testing the entire application as a whole. They simulate real user interactions with the entire system, from the user interface down to the backend services. They're excellent for ensuring that our entire application works seamlessly from the user's perspective. Now, a common question that I get is, what types of tests should we write? Well, the classic recommendation is to have more unit tests than integration tests, and more integration tests than end-to-end tests. This is referred to as the testing pyramid. However, this is just a suggestion. It doesn't mean we should follow it religiously, because every application is different. In some cases, it may make more sense to have more integration tests or more end-to-end tests. There is no one-size-fits-all in software engineering. Anyone who tells you there is only one way to do something and that's the best way, they're either selling you something or they haven't been around long enough. So when designing a testing strategy for your application, consider the complexity of your application's code, as well as your time and resources to come up with a suite of tests that give you the most value. But there is one thing crucial you need to understand about the testing pyramid. As we go up this pyramid, in other words, as we test more units of our code together, our tests will be slower, and they will give us more confidence in the reliability of our application. So end-to-end tests give us the highest confidence, but they're significantly slower. Running them every time we change or refactor our code isn't always feasible. This is where unit tests come into play. Unit tests are incredibly fast, so we can run them every time we change or refactor our code to get immediate feedback if we have broken something. So, all these types of tests are valuable. It's hard to determine which type has more value. It's like debating what type of shoes is more valuable, dress shoes or running shoes. Well, it depends where you want to go. So don't listen to folks with strong opinions on social media saying things like unit tests are a waste of time and they only write end-to-end tests. Good for them. Anyway, in this course, our focus is entirely on unit testing, so you don't need to worry about integration and end-to-end testing at this point. In the second part of this series, where we'll look at testing React applications, we'll talk about integration tests. So I mentioned earlier that we need a test runner to execute our tests. Now this is where testing frameworks come into the picture. A testing framework is a set of tools for writing and running tests. It typically includes a test runner for executing tests, assertion libraries to check if the code behaves as expected, mocking tools to replace certain modules with fakes, simulating different scenarios, test coverage tools for measuring how much of the code is tested, and many other tools. Now, there are several testing frameworks out there like Jest, Mocha, Jasmine, VTest, Cypress, Playwright, and many more. All these frameworks work more or less the same way. So once you get the hang of one, you can easily pick up other frameworks. Among these, Jest is the most widely adopted and used in many projects. However, there is a little catch with Jest. It's an older framework and support for ECMAScript modules or native JavaScript modules is still experimental, so setting up things can be a little bit awkward. So in this course, we're going to take a different route. We'll be using VTest, which is a new testing framework designed for modern JavaScript. It has all the fantastic features of Jest, as well as out-of-the-box support for ECMAScript modules, TypeScript, and JSX, which is used in React. Plus, its API is almost identical to jest. So everything you learn about V-test in this course will be directly applicable to jest as well. Alright, now we're ready to set up V-test. So I have opened our starter project in VS Code. Now we need to open a terminal window to install V-test. So on the top, under the View menu, let's go to Terminal. Look at the shortcut. It's Control and backtick. So here we're going to use npm to install V-test as a development dependency. Because we don't want to deploy our test tools with our application, so we always install them as development dependencies. So let's install V-test. Lovely. Now we need to go to our package.json file and create a test script. So here in the scripts object, we add a new key value pair called test and set it to V-test. Now, whenever we run npm test, V-test will execute our tests. So if we go back to the terminal and run npm test or npm t, V-test will execute our tests. Now, currently we don't have any test files, that is why we get this error. In the next lesson, we're going to create the first test.
Tralalero tralala did it.
Alright, we're going to write our first test. So here in the source folder, we have a module called intro. In this module, we have all the code we're going to use in this section. So here we have a function for getting a max of 2 numbers. Pretty basic. If a is greater than b, it returns a. Otherwise, if b is greater, it returns b. Otherwise, if they're equal, it returns a. I know this is not the best way to write this function. This is deliberate. Once we cover this function with tests, we'll come back and refactor it into a more elegant implementation. So to test this, we're going to go in the root of our project. Next to the source folder, we create
Ballerina cappuccina. Mi 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 mi.
Test file
È la moglie di Cappuccino assassino.
So we call it intro test.js. This is the Of course, this can be in this file, we're going to import a few functions from one of them is describe, test, the other one is test, there's also another function called save job. We talked about it one function so first we call this first argument so here we have an arrow function. Now, in this block or in this test suite, we define one or more test cases. So we call test or it doesn't matter, it's a matter of personal preference. Now, just like the describe function, here we need 2 arguments. The first argument is a string that represents our test name. So look, here we want to test a scenario where A is greater than B. So to name this test, here we can pass a string like should return the first argument if it is greater. Now look, the reason some people prefer to use the it function is because the test case reads like it should return the first argument if it's greater. Very clear. So always pay great attention to naming your tests. I've seen some people naming their tests like test 1, test 2. Don't do that, because over time, it's not going to be clear what is the purpose of these tests. So always treat your tests as first-class citizens. Your test code is as important as your production or application code. Okay? So here's the test name. Now the second argument should be a function that will be executed by our test runner, in this case vtest. Once again, we pass an arrow function. Now in this test, we typically structure our test using the AAA pattern. That is short for arrange, act, and assert. This is a pattern that a lot of people follow when organizing their tests. In the arrange phase, we set up our test environment, including any necessary data or configurations. In the act phase, we perform the action we want to test, And in the assert phase, we check the outcome to ensure that it matches our expectations. Let me give you a real example. Imagine we want to test that a TV can be turned off. In the arrange part, first we turn on the TV. In the act part, we press the power button. And in the assert part, we verify that the TV is off. Okay, now we can take this analogy and apply it to our tests. So, in the arrange part, first we declare two variables or two constants. We can call them A and B. We set A to 2 and B to 1. Now, these are arbitrary values. We could use 20 and 10, we could use 10 and 9. It doesn't matter. What matters is that we want the first argument to be greater. Now, in the act phase, we perform the action we want to test. In this case, we call the max function that is defined in this module. So let's press enter. The max function is imported on the top. Now we pass our arguments A and B, get the result, and store it here. Now, finally, in the assert phase, we verify that the result is correct. To do that, first we call the expect function of vtest. And by the way, Jest has the same functions, and they work exactly the same way. So we call expect and pass result. Now, this returns an expectation object. In this object, we have a bunch of methods that start with to. These are called matchers. We use these to verify expectations. For example, we have to be called, to be defined, to be falsy, to be greater than, and so on. As we go through the course, we're going to get familiar with these matchers. In this lesson, we're only going to use the to be matcher. So we expect the result to be 2. This is how we structure our test. Now, we don't necessarily have to add these comments. We can use a vertical line break to separate these sections. This way, it's immediately visible that the first part is the range part, the second part is the act part, and so on. Now, for simple cases, we don't even have to have all these parts or all these phases. We can combine them to make our test more concise. For example, we don't need to declare these two constants because they're only used on this line. So we can replace A and B with their literal values. Now we don't need the arrange part. And similarly, we can combine these two lines into a single line. So we replace result with a call to the max function. Now our test has a single line of code. So back in the terminal, let's run npm test or npm t. Alright, we have one passing test, beautiful. And look, the test name clearly identifies the scenario we're testing. Now, back in our test, if I change this value to 1, now back in the terminal, look, now we have a failing test, and the failure is happening on line 6 of this module. So the test expected 1, but it received 2. So back to our test, let's change it back to 2. That was our first test case. Now, we need 2 more test cases for scenarios where the second argument is greater and also the scenario where our arguments are equal. So I'm going to duplicate these 3 lines. So here's what we have so far. In this test suite, we have 2 test cases. Now let's change the name of the second test, and here we say it should return the second argument if it's greater. Now let's swap the order of these arguments. Back in the terminal. Now we have 2 passing tests in 1 test track. And 1 more test case. I'm going to say it should return the first argument if arguments are equal. So here we can pass 1 and 1 and expect the result to be 1. Now take a look. Now we have 3 passing tests, and all these tests were executed in 8 milliseconds. Imagine if we wanted to test this function through the UI. Perhaps we have to do a few clicks, perhaps we have to fill out a form. Obviously, we could never do this in 8 milliseconds, right? It would take several seconds. But we are not done yet. Now that we have fully covered this function with tests, let's refactor it with confidence. So we're going to replace these 3 lines with an expression like this. Return, if A is greater than B, return A, otherwise return B. Back in the terminal, look, our tests are still passing. This is the beauty of unit tests. They give us immediate feedback if we have broken something during our refactorings. However, if we go back here and let's make a deliberate mistake, let's return A in both cases. Now look, one of our tests failed, and that is this particular test should return the second argument if it's greater. So we expected to get 2 what we received. So let's go back and fix the error. Alright, so that was our first test. Now as we go through the course, we're going to look at more complicated and real-world examples. Alright, here's your exercise. In the same module, we have a function called visibuzz. It's a very popular function that comes up in coding interviews. So this function receives a number. If the number is divisible by 3 and 5, it returns fizzbuzz. If it's only divisible by 3, it returns fizz. If it's only divisible by 5, it returns buzz. Otherwise, if the number is not divisible by 3 or 5, it returns the number as a string. Now, as your exercise, I want you to cover this function with tests. Now, to give you a hint, when writing tests for a function, you should cover all the execution paths. So here we have 4 execution paths. Here's the first one, second, third, and fourth. Spend 5 to 10 minutes on this, and then come back to my solution. So, back to test 5. Here we have a test suite for the max function. Now we need to define another suite for testing the fizzbuzz function. So we call describe as fizzbuzz. Now here we have a scenario where the argument is divisible by 3 and 5. So it should return fizzbuzz if argument is divisible by 3 and 5. I'm going a little bit faster because I'm assuming you have done your exercise. Then we pass an error function. Now once again, here we don't need to have separate arrange at and assert traces. We can combine all of them into a single line because our test is very simple. So we call fizzbuzz and give it a number like 15. Then we make an assertion and check to see if the result is fizzbuzz. Now back in the terminal, beautiful, we have 4 passing tests. Now to make sure that you're testing the right thing, let's change this to fizz. Now we have one failing test, lovely. So let's revert it back to fizzbuzz. This is a very simple and useful technique to ensure that you're testing the right thing. Because sometimes your test might pass, but it might not be testing the right thing or even the right function. So always make a tiny change to make sure that your test and production code are in sync. Another way to go about this is by modifying the production code. So instead of changing the test code, we can go back to the production code and create a bug.
Il mio cappello è pieno di slim, nel bosco fitto e misterioso.
Now, look, one failing test. This verifies that the test code and the production code are in sync. In other words, our test has actually tested this function. Because otherwise, let me show you an exact repetition. Let's imagine, instead of calling to be, we had a call to be. So we're checking that the value that is returned from this function is 5. With this test, now our test always passes, even though the bug function. If you make any changes here, the test still passes. It shows that we are not testing the right thing. This is what we call false positive. So our test always passes, giving us an illusion that the code works. We can also have false negatives, tests that always fail even though there's no bug in the production code. So this technique is very useful if you have false positives and false negatives. We want to make sure that the test code and production code are in sync. In other words, we're testing the right thing. So let me bring back the 2B matcher and compare the result with fizzbuzz. Okay, now we have a failing test, lovely. So let's go back and fix the bug.
Round 1.
Good. So we're done with the first test case. Now let's move on to the second test case. So I'm going to duplicate these few lines. This time we say that our function should return fizz if argument is only divisible by 4. So we can pass 3 or 6 or 9, it doesn't really matter. Let's compare it with fizz. We have one passing test. Now to make sure that we're testing the right thing, again, we can go back to our production code and make a tiny change here. There you go. Now we have a failing test, so our test and production code are in sync. Now we need 2 more test cases, so let's duplicate this test and change the name to it should return buzz if argument is only divisible by 5. So here we pass 5 and compare the result with buzz. One more passing test and the last test case. It should return
Round 2.
argument as a string if it's not divisible by 3 or 5. Okay. So let's pass 1 and here which thing we get 1 passing string. 7 passing test. But if you pass 1 passing number, now okay, so let's revert it back. We're done with this test set. Next, we're going to talk about test-driven development. There are 2 ways to write tests: code first or test first. Code first is what we have been doing so far. We write the application code first, and then we cover the tests. Test first is the opposite. We start with tests, and then we produce the application code. This approach is also called test-driven development or TDD. TDD is a way of building software. It follows a simple and effective 3-step cycle. You start by writing a failing test, and then you write just enough code to make the test pass. Then, if necessary, you refactor our code while ensuring that all tests still pass. And then we repeat. Let's see this in action. So let's imagine we want to create a function for calculating the average of values in an array. So we start by writing a failing test. So back to our test file, first we create a new test suite. Let's call this calculate average. Now here we start the test case for an empty array. Let's say that if we pass an empty array to this function, we expect to get not a number. So it should return not a number if given an empty array. Now first we need to create this function. So back to our intro module, we define a function called calculate average that takes an array of numbers and then export it from this module. So we're not going to implement this yet, we just have the declaration of the function. Now, back to our test. So we call calculate average and within an empty array, and then expect the result to be not a number. Okay, back in the terminal, look, we have a failing test because we expected not a number, but we received undefined. Because in JavaScript, all functions by default return undefined unless we explicitly return a value. So to make this test pass, we go back to our intro module and write the simplest implementation possible. So we return not a number. Now, we have one passing test here. That was one cycle. Now we need to repeat this with other test cases. So as our second test case, we're going to call this function and give it an array with a single element. So we can change the test name to should calculate the average of an array with a single element. So we call it and give it an array with just 1 and expect the result to be 1. Now look, again, we have a failing test, so we have to write just enough code to make this test pass. So back to the intro module. Now we can say if numbers, the length equals 0, then we return not a number. Otherwise, we return numbers of 0. Obviously, this logic is still immature, but we're going to enhance it with more test cases. So back in the terminal, now we have 9 passing tests, so we completed one more cycle. Now let's write another test case for an array with 2 elements. So back to our test file, let's duplicate this test case and say it should calculate the average of an array with 2 elements. So if you pass 1 and 2, we expect the average to be 1.5. Now look, again, one failing test. So we go back to our intro module and write a simple logic here. We can use a for loop to iterate over this array and calculate the total of all values, or we can use the reduce method. So here we call numbers.reduce and give it an arrow function. This function should have 2 parameters. The first parameter is an accumulator or a variable that contains the total value. We can call it total or sum, that's better. The second parameter holds the current value, one value at a time in this array. So we can call it current. Now in the body of this function, we simply add current to sum. So we return sum plus current. So this function is the first argument to the reduce method. Now, as the second argument, we need to provide the initial value for the sum. So we initialize it to 0. Now with this we get the sum of all numbers in this array, and finally we can divide sum by numbers dot reduce. Now back in the terminal, all our tests are passing, lovely. So let's write one more test case. This time we will pass an array with 3 elements. So if you pass 1, 2, and 3, the average should be 2. Now look, alright, all our tests are passing. So this was TDD in action. We started by writing tests, and as a result, we produced this function. Now, the beautiful thing about TDD is that it produces production code that is 100% covered by tests. So here we don't have any execution paths that we haven't tested. The current implementation of this function is fully covered by tests. If the implementation is not complete yet, we can add other test cases to drive the development. The other great thing about TDD is that it prevents us from over-engineering because our focus is on writing the simplest logic to make the tests pass. And we can always refactor and refine our implementation. What matters is that we're not over-engineering ahead of time. So these are the benefits of TDD. But in practice, TDD can be difficult, especially for new learners. So in this course, our focus will be on the code-first approach. But as you learn unit testing, you can challenge yourself and start exploring TDD. First, it might be difficult, especially in more complex applications, but trust me, over time, with practice, it gets easier and easier. Now, I just want to clarify something here. TDD as a philosophy is great, but it doesn't mean that you should always rate tests using this approach. I know that there are some folks that are fanatic about TDD and they say, you're not a developer if you don't use TDD, but again, this is one of those extremely radical viewpoints. If you don't like TDD or if you prefer to write tests after production code, that is perfectly fine. Again, there's no one-size-fits-all in software engineering. Every project, every team is different, so always use the approach that works for you and your projects. Now, as your exercise, I want you to implement the factorial function using TDD. We have all studied factorial at school in math. Now, to refresh your memory, the factorial of a number is the product of all positive numbers from 1 to that number. Here are a few examples. So factorial of 0 is 1, factorial of 1 is 1, factorial of 2 is 2 times 1, factorial of 3 is 3 times 2 times 1. So write a test case for each of these scenarios and then implement the factorial function. Alright, so we start by creating a new test suite called factorial. First, we write a test case for the factorial of 0. So should return 1 if given 0. Now, first we need to create a factorial function, so back to our intro module, we export function called factorial, it takes a number, and we leave out the implementation. Now, back to our test, we call factorial, and give it 0, and then we expect the result to be back in the terminal. Obviously, we have a failing test, so to make this test pass, we go back to our intro module and return. Alright, our test is passing. Now the second test case. So we duplicate this and change the test name to, it should return 1 if given 1. Our tests are still passing correctly, so let's have another test case. Should return 2 if given 2. Now back to our function. Here we need a bit of logic. We can check if n equals 0 or 1, then we return 1. Otherwise, we can do a trick. We can just return 2 to hardcode this value, and our tests are still passing. So what I want to emphasize here is that we want to write just a little bit of code to make our test pass. We want to do baby steps. We don't want to have a big step where we write a lot of logic, because that can lead to over-engineering. So our tests are still passing. So let's add another test case. Should return 6 if given 3. So factorial of 3 should be 6. Now, one of our tests is failing, so we go back to our factorial function, and this is where we make another step. So instead of hard coding 2 or 6, we implement the actual logic. Here we can use recursion, so we multiply n by factorial of n minus. All our tests are passing correctly. Let's add one more test case. What if we pass 4? Factorial of 4 should be 24. Right? All our tests are still passing. Beautiful. Now, what if we pass a negative? Well, that's one of the areas that is debatable, but we can say that factorial of negative numbers is undefined. So, we write another test case here and say it should return undefined if given a negative number. So we pass -1 and expect the result to be undefined. Now we also have a separate matcher function here that is to be undefined. We can also use this. Back to the terminal, one of our tests is failing, so back to our factorial function, let's add another if statement and say if n is less than 0, then return undefined. All our tests are passing. Lovely. Now I just want to clarify something here. As part of writing tests, whether we go with the code first or the test first approach, we don't want to test against all possible numbers in the world because that is not practical. So we don't want to test a factorial function with a million different numbers. We want to have enough numbers in different ranges like 0, positive, negative. As long as we have a few different test cases for different scenarios, that is sufficient. Alright, what's next? Well, if you want to learn more, I have a comprehensive JavaScript unit testing course on my website. What you have watched is the first 40 minutes, but the full course is 4 hours long and goes way beyond the basics. We'll talk about various techniques for writing effective tests that are robust, maintainable, and trustworthy. We'll talk about positive and negative testing, boundary testing, writing parameterized tests, testing asynchronous code, and using mocks and spies to isolate code during tests. We'll also have a section on improving code quality using static analysis tools. We'll talk about formatting code with Prettier, linting it with ESLint, catching type errors with TypeScript, and automating code quality checks with Husky. So by the end of the course, you'll have a strong foundation in unit testing, and we'll be ready to learn about testing front-end applications like React. The full course is packed with a ton of exercises so you can practice what you learn. And the best part is that it comes with a certificate of completion and a 30-day money-back guarantee. So if you're not satisfied, just ask for a refund. If you're interested, use the link below this video to enroll. I hope to see you in the course. Thank you and have a great day. Welcome to the complete React testing course. In this course, you're going to learn everything necessary to write effective, valuable, and maintainable tests for your React applications. If you have been searching for a comprehensive, easy to follow, well-organized, and practical course that takes you from 0 to hero, this is the right React testing course. This course is packed with a ton of coding techniques I've learned over 20 years in software engineering. Plus, it's packed with numerous real-world exercises designed to help you master React testing. By the end of this course, you'll have the skills and knowledge to confidently test React applications like a pro. This expertise will set you apart in the world of software development, opening doors to exciting opportunities and challenges.
I'm Mosh Hamadani, a software engineer with over 20 years of experience, and I've taught millions how to code and become professional software engineers through my YouTube channel and online school called Mosh.com.
So, are you ready to elevate your React skills? Let's dive in and get started. I promise, by the end of this course, you will look at unit testing in a whole new way. If you are new here, welcome aboard. Make sure to subscribe as we upload new videos all the time. Let's talk about what you need to know to take this course. First and foremost, you should have a good grasp of React because we're testing a React application in this course, so you need to know all the essential concepts like components, hooks, state management, routing, and so on. If you want to brush up on your React skills, I have a couple of comprehensive courses on my website, so feel free to check them out. Now, if you're watching this video on YouTube, I've put the links below in the description box. You can also go to codewithmosh.com to see all my courses. Now, the React application we're going to test in this course is written with TypeScript, so you should know the basics of TypeScript as well. Don't worry, you don't need to be an expert, just knowing the basics is enough. You should know how to define types and annotate your objects with types. That's all. Now, if you want to learn TypeScript, I have a 1-hour tutorial on my YouTube channel, as well as a comprehensive course on my website. Again, the links are below this video. Now, there is one more thing you need to know. You should know the basics of unit testing plain JavaScript code without any UI frameworks. More specifically, you should know how to write basic unit tests and make assertions. So I'm assuming you know the basics of unit testing, and in this course, you want to learn how to test React applications. Now, if you want to learn the basics of unit testing JavaScript code, again, I have a 1-hour tutorial on my YouTube channel, as well as a comprehensive course on my website. Now, assuming that you are the right student for this course, let's move on to the next lesson. Alright, before we jump in, let's take a quick look at what we'll cover in this course. Shortly after this video, we're going to set up our development environment and get all the testing tools we need. In the next section, we'll explore testing React components with the React testing library. This is where the fun begins. You will learn how to use this powerful library to write tests that are maintainable and closely resemble how your web pages are used. Then we'll talk about mocking APIs. You will learn how to write tests that are robust and independent of external factors. Next on our list is testing forms. Forms are crucial in user interaction, and I will show you various techniques to make sure they work flawlessly every time. Moving forward, we'll delve into testing state management. In this section, we'll look at a few examples involving React context, Redux, and React query. After that, we'll talk about testing authentication, and in the final section, we'll cover testing routing. Now, a lot of people struggle with unit testing. Why? Because they don't know how to write good tests. They spend a lot of time writing and fixing low-quality tests. These tests get in the way, slow you down, and can be really frustrating. But don't worry, because throughout the course, I'm going to show you various techniques to write tests that are not just good, but great. These are the techniques I've learned and mastered over 2 decades of working as a software engineer. So I will show you how to write tests that are effective, valuable, and easy to maintain. So there's a lot to cover, and by the end of this course, you'll be really good at testing React applications. I promise. Before we start coding, let's talk about how you should take this course. First off, as you learned in the previous video, I've structured this course so it's super clear and easy to follow. Now, you might be tempted to just jump to the section that seemed relevant to you, but here's my advice: don't do that. Even if you have been writing tests for a while, you might have picked up some bad habits along the way. That's why I suggest starting from the beginning and watching every single lesson. Because throughout the course, I share a bunch of shortcuts for navigating your code base and writing code quickly. If you skip around, you might miss these and feel like the course is moving too fast. Trust me, these tips are game changers. Now let's talk about exercises. This course is incredibly hands-on and is packed with real-world exercises. In fact, more than half of the course is dedicated to these practical exercises. If you really want to get good at testing, you need to do these exercises. And don't just do that, make sure to watch my solutions as well. That's where I share the techniques I've learned and refined over 2 decades of working as a software engineer. These aren't your everyday tips and tricks. You probably won't find them in most other courses. I promise, every minute you spend on this course is going to be worth your time. Lastly, this course comes with a couple of GitHub repositories. There is one for the starter project and another one for the finished project, which includes all the code they write in this course. For each lesson, you have a separate committee. This way you can see the exact code I write in that lesson, step by step. So that's how you can get the absolute best out of this course. Follow it step by step and complete all the exercises. I can't wait to see how much you learn and grow as a software engineer.
Round 3. Fight.
Alright, before we get started, let's make sure you have the necessary tools installed on your machine. First, head over to nodejs.org and download the latest version of Node. This is really important because sometimes in newer versions of Node, there are optimizations that make your tests run faster. So make sure to download the latest version of Node. Now, in addition to Node, we're going to use Git to manage our source code. These days, pretty much everyone has Git on their machine, but if you don't, head over to git-scm.com and download the latest version for your operating system. Now, in this course, just like my other courses, I'll be using Visual Studio Code or VS Code as my editor. You're welcome to use your preferred editor, but I highly recommend you to use Visual Studio Code because it makes it easier to follow along. Plus, I'm going to show you a lot of shortcuts to boost your productivity and have fun coding. Alright, now let's set up the starter project for this course. Head over to github.com/mosh-hamedani. Then go to repositories. Here we have 2 repositories for this course. React Testing Starter, which is our starter project,
patapim,
and
il mio
React
cappello è
Testing
pieno di
Finish,
slim,
which is
nel
the
bosco fitto e misterioso.
So let's go to React Testing Starter. And here you can find all the details on this project. You can see that our project uses +0 authentication and is built with Tailwind, Radix UI, React Router, and Redux Toolkit. Ideally, we should have basic familiarity with all these technologies and libraries, but if not, it's still fine. So the first thing we have to do here is setting up auth0 authentication. So head over to auth0.com. If you don't have an account, sign up. It's free and takes 2 minutes. Then, once you log in, here on the dashboard, on the left side, go to Applications and create a new application. You can call this whatever, it doesn't really matter. I'm going to call it BRAINROT. Now we go to the settings page. Here we have to set up a few settings. First, we have to set an application to send a page application. Next, we set allow callback URLs. We set it to HTTP, localhost, port 5173. This is the port that our project uses. Now I'm going to copy this address and paste it in allowed logout URLs box, as well as allowed web origins. Then we save the changes. Alright, good. So we're done with setting up Auth0. Now we need to go back to GitHub and clone this repository on our machine. So let's grab the code. Then we open a terminal window and clone this repository. Alright, now let's go to React Testing Starter. First we need to install all the dependencies. Alright, good. Now let's open this with VS Code. Now here in the root directory we have the .env file. We're going to take a copy of this for storing our local environment variables. So let's make a copy and rename this copy to .env.local. Now we need to replace the Auth0 domain and client ID with the values of our Auth0 application. So back to the settings page of our application. On the top you can find the domain and client ID. Let's copy these values and paste them here.
Round 2.
And one more time with the client ID. Lovely. Now let's go to package.json. So look, here we have a few scripts. We have the server script for starting the backend. Our backend is implemented with JSON server. So JSON server uses this file, db.json, to serve data to our application. Now in a real application, you're not going to use this, you're going to use a database, but it doesn't really matter as far as testing is concerned, because here we're not going to use the real backend. We're going to mock the backend and test the front end in isolation. Now here we have a script for starting the application using concurrently. So using this package, we can run both the backend and front end in parallel. So back to the terminal, let's run npm start. Our backend starts at localhost port 3000, so make sure you don't have any other applications running on that port. And our front end starts at port 5173. So let's take a look. Here's our application. It's not a full-fledged application, but it has a few cool features and patterns that you find in a lot of real-world applications. For example, on the top, we have a selector for selecting a language. Currently, English is selected. If we change it to Spanish, now the message changes here. Let's go back to English. So this is implemented using React Context. Now let's go to the product page. Here we have a list of products that are fetched from the backend. We can add them to our shopping cart, and the number of items in the shopping cart is updated on the top. We also have an admin area that is protected. Here we get redirected to the universal login page on Auth0. So let's sign up with a new account. Alright, let's authorize our application. Alright, I'm logged in, and now I have access to the admin area. Here we have the products page, where we can manage our products. We can add a new product. We have a basic form. Let's add product 1, give it a price. Now here we have full validation, so if we submit the form without supplying any values, we get validation errors. So let's give this a price of $10 and assign it to a category like electronics. Here's our product, we can also edit it. Let's change the category to appliances. Good. Now we get this toast notification on the top, beautiful. Now finally, if we log out, we get redirected back to the homepage. So we have a few interesting patterns and features that you find in a lot of real-world applications. Now to test this application, we need a testing framework. As I told you in my JavaScript testing course, there are many testing frameworks out there like Jest, Mocha, Jasmine, VTest, and so on. Jest is probably the most popular testing framework, but the problem with Jest is that its support for ECMAScript modules or native JavaScript modules is still experimental. So setting things up is a little bit awkward. So in this course, we'll be using VTest, which is a relatively new testing framework built for testing modern JavaScript applications. So it has built-in support for ECMAScript modules, as well as TypeScript and JSX. So back to our project. On the top, let's go to View, and then Terminal. Look at the shortcut, it's Control and backtick. So now we have a terminal window pointing to our project directory. Let's install vtest as a development dependency. Good. Now we need to create a test script in our package.json file. So on the top, under the Go menu, look at the shortcut for going to the file. On Mac it's Command and Key, on Windows it's probably Control and Key. So now let's go to our package.json file. Here in the script object, we need to add a new script. Let's call it test and set it to vtest. Now, I would prefer to create another script for running tests using the vtest UI. So let's call this test:UI and set it to vtest with the UI option. Now let's create a basic test to make sure that our setup is done properly. So, back to our project. Here in the root directory, we add a new folder. Let's call it tests. Here we add a new file. Let's call it main.test.txt. Now here on the extensions panel, I want you to search for vtest. We have this very useful extension called vtest snippets. It's from this developer, Dean Software. With this extension installed, here we can import the essential functions from vtest by typing IV, that is short for import vtest. So now we have id, expect, and describe from vtest. Now to create a test suite, we type D followed by enter. The name doesn't matter. Let's press tab. Now to create a test case, we type I followed by enter. Now I don't know why I have two instances in the auto completion box. The one we need is the one with this square icon. That is the code snippet. So let's select that. Now let's write the basic assertion and say expect 1 to be true. Now let's go back to the terminal window and run npm test or npmt to run tests in the terminal. Alright, our test passed, beautiful. Now let's quit and run tests using vtest UI. So npm run test :UI. Now the first time it's asking if you want to install vtest UI. Let's select yes. Alright, good. Now we need to run this command one more time. Alright, here's vtest UI. Throughout the course, we're going to use this interface to run our tests because it's much easier to see what's happening as opposed to running tests in a terminal window. Now, I don't like the light mode, so let's change it to dark. That's easier on eyes. So we have one passing test. Beautiful. We're done with setting up vtest. Next, we're going to set up React testing library. To test React components, we need a few tools. The first one is React testing library, which allows us to render our components and interact with them just like the end user. So let's go back to the terminal and install React testing library as a development dependency. So add testing-library/React. And the version I'm going to install is 14.2.0. I recommend you to install the same version so you have the same experience as what you see in the videos. Good. Now, the next library we need is JSDOM. What is this? Well, by default, our tests are executed in a Node environment, but Node doesn't know anything about browser APIs like the DOM. So to test our React components, we need to run our tests within an environment that emulates the browser environment. We have a couple of options here,
yang banyak meresahkan masyarakat akhir-akhir ini.
Which is faster on Mac, so we're going to start with JSDOM, and later so terminal let's install JSDOM as a developer dependency, and the version I'm going to install is 24.0. Now we need to make a configuration file for vtest and tell it to use JSDOM as the test environment. So after let's add a new file. Now here on top, first we have next, set the environment as a configuration object, so we export it as a default object. Whenever we change VTest configuration, we have to restart VTest. So back to our terminal window where we are running VTest UI. Let's press Q to quit and rerun npm run test UI. All right, good. Now the last library we need is testing library /JSDOM. This library gives us a bunch of matchers for writing assertions against the DOM. For example, we can check to see if an element is in the DOM, if it has the right content, and so on. So back in the terminal, let's install one more library, and that is at testing-library /jest-dom. Welcome back to the complete React testing course. In this section, we're going to dive deep into the world of testing React components. We'll kick things off by understanding what to test and what not to test when it comes to testing components. We'll then jump right in and explore testing rendering and user interactions. We'll also look at a few techniques you need to know to test components that use component libraries like Radix UI, Material UI, and so on. Throughout this section, I will also show you a few techniques to simplify your tests and make them more maintainable. And finally, we'll wrap up this section by talking about using ESLint to catch common issues in the code. This is a foundational section in the course, so make sure to watch every lesson and complete every exercise. With that, now let's jump in and get started.
Las capuchinitas dicen capuchina. Las tralaleritas dicen tralalí.
Before we dive into writing tests, let's take a moment and talk about what exactly we should be testing and perhaps more importantly, what we can skip testing. When it comes to testing React components, there are two major concerns we need to test: how they render and how they respond to user actions. For rendering, we should verify that our components render correctly under various conditions. If a component has props, we should pass different props and verify that it renders correctly. If our component handles user events like clicks, keyboard inputs, or anything similar, we should simulate those and check if it reacts the way we expect. Now, in my JavaScript testing course, we talked about the importance of creating tests that are maintainable, robust, and trustworthy. I mentioned having no tests is better than writing bad tests, because poorly written tests can get in the way and slow us down. Now, one of the best practices I touched on was testing behavior and not the implementation. In simple words, that means we should test what our application does, not how it's implemented. As an analogy, think of testing a TV. We use the remote, press buttons, and watch what happens. We don't care what's inside the TV, right? Similarly, testing a component, test what it does and how it's implemented. If our component uses hooks, context, or users, these are all implementation details. We should not write tests against those details, because if the implementation details change in the future, tests will break, even if our application still works fine. So, for the most part, we shouldn't test building blocks like hooks and reducers in isolation unless they're used by several components and have complex logic. In those cases, yes, it makes sense to unit test those pieces in isolation. But for the most part, we should test them as part of testing our components, which is what we call integration testing. Now, you have probably seen this test pyramid before. The test pyramid suggests that we should write more unit tests and integration tests, and more integration tests and end-to-end tests. This is just a guide, not a strict rule. So when testing React applications, we often lean towards integration tests. Our tests might be slower than unit tests because we'll be testing several units together, but they give us better confidence that our application works. Plus, our tests are less likely to break or refactor some code as long as the end result stays the same. The other thing you should avoid is testing styles. Why? Well, visual tests can be fragile. A tiny style change, like changing the font size or color, can fail a test, and honestly, passing visual tests don't guarantee that your application looks good. That's a job for our own eyes. So, instead of wasting our time testing styles, we should test our application's behavior and functionality. That's where the real value is. Alright, theory time is over. Let's dive into some real examples of component testing as we move forward. Alright, let's write our first test. Here in the source folder, inside the components folder, we have a component called greet. A very simple component with a name prop of type string. If we provide a name, our component renders a heading. Otherwise, it renders a login button. So here we need two test cases. In one test case, we provide a name and assert that we have a heading with its content in the DOM. In the other test case, we don't provide a name and assert that we have a login button in the DOM. So, back to our project, we go to our tests folder and create a new folder here called components. Now, in terms of test organization, there are two schools of thought. Some people prefer to have all their tests inside the tests folder. Other people prefer to have their tests next to their components. There is really no right or wrong here, but most of the community prefer to have their tests inside the tests folder. This also makes things a little bit easier when working with continuous integration and deployment tools. So in this course, we're going to put all our tests inside the tests folder. Now here we have a folder for our components, so all our component tests are in a single place. Now we create a new file called greet.test.ts. Now note that here we are using capital G because that's how we name files that have React components. Now in this file, first we have to import the essential functions from vtest. So iv, then we create a test suite for the greet component. Here's our first test case. It should render hello with the name when name is provided. Now here first we have to render our greet component. To do that, we have to import the render function from React Testing Library. So add testing library /React. So we call render. Now here we need to pass our greet component. Now because we're going to write some JSX expression here, we have to rename our file from TS to TSX. So let's rename our file to TSX. Good. Now here we can render our component, our greet component. Now in this case, VS Code auto-imported this for me on the top. If your editor doesn't do it, make sure to import greet from the right location. So we render greet and set the name prop to, let's say, Mosh. So this render function renders our component into a virtual DOM that is implemented by JS DOM, the library we installed in the first section. Okay? Now, to see the state of the DOM, we can use the screen object. So on this line, we also import the screen object. Now, after we render our component, we call screen like the test UI in the browser, yes, we can start screen test here on the console tab. This is the state of our virtual DOM. We have body, div, and our heading. Now, to complete our test, we have to find this heading in the DOM and make an assertion against it. To do that, we have to use one of the query methods in React Testing Library. If we search for React Testing Library queries on this page, here we have a bunch of query methods like row, label text, placeholder text, and so on. Most of the time we prefer to use row because this makes our tests more robust and less prone to changes when we change it. For example, if we change some text, class names, or elements, and the test using this query method is less likely to fail compared to one that relies on text or class selectors. Okay? Also, this query method encourages us to interact with our components just like the end user, focusing on accessibility features. So, back to our code. Here we call screen get by role. Now here we have a bunch of standard roles like alert, article, banner, and so on. Here you want to select an element with the role of heading. This returns any kind of heading like h1, h2, and so on. Now we store it in an object. And finally we need to write our assertions. So just like unit testing JavaScript code, we start with expect, we pass our heading object. Now here we need to use one of the matchers that comes with testing library. So on the top, we import add testing library /jest/dom/test. Now if you're using jest, you have to modify your import statement. In this package, we have a bunch of custom matchers. You can find them all by searching testing library jest.dom. On this GitHub page, you can find all these custom matchers that to be disabled, to be enabled, to be in the document, and so on. You don't have to memorize any of these. As we go through the course, as we work on more exercises, you will gradually get familiar with these matchers, okay? So back to our code. Now let's finish our assertion. So we expect heading to be in the document. Okay, back to VTest UI. We have one passing test, beautiful. Now in my JavaScript testing course, I emphasize the importance of testing the correct behavior. So to prevent false positives or tests that always pass, we can go to our production code, make a tiny change, and see if our test fails or not. So let's go back to our create component. We can comment out the line of code that should make our test pass. Now if our test fails, it means that we are testing the correct behavior. Now look, our test failed, good. We can look at the report tab to see what's happening. Down here, you can see the state of the DOM. So we have the login button, but we were searching for a heading. So back to our create component, let's bring this back, good. Now we can write a second assertion and ensure that our heading has the right content. So we expect heading to have text content. This is another custom matcher that comes with testing library. Now here we can pass a string or a regular expression. It's often better to use a regular expression to make our tests more robust. So here we pass a regular expression and search for hello Mosh. And we want to make this case insensitive. Now if in the future we replace hello with hi or good morning or whatever, our test is going to break. So we don't want to be over specific here. We want to make our assertions a little bit looser or more general, okay? Now, again, our test is passing great. So we're done with our first test case. Now let's repeat and create a second test case. To save time, I'm going to duplicate this test case. I'll change the test name. Should render login button when name is not provided. Now if we remove the name prop, we get a compilation error saying property name is missing because our greet component always expects a name. So here we have to pass an empty string, but this looks a little bit ugly. So to make our component more flexible, we can make the name prop optional. So right here, we have a question mark, and now we don't have to supply the name prop. Alright, good. Now, in this test case, we get an element by the role of button. Let's change the name of this constant to button. First, we expect our button to be in the document, and then we assert that it should have the right content. In this case, login. Now, look, we have two passing tests, great. Once again, to verify that we are testing the correct behavior, we go to our production code and comment out the line of code that should make our last test pass. Now our test failed, so that means we're testing the correct behavior. So let's bring it back. Alright, we have learned how to write basic tests using React Testing Library. Now there is a problem with our setup. Every time we want to create a test file, we have to add these import statements on the top. This is repetitive and cumbersome. So in this lesson, I'm going to show you a few techniques for simplifying our test setup. First, we don't have to import these functions from vtest in every single test file. We can go to our vtest configuration file and turn on globals. So let's go to vtest.config.ts. Here in this test object, we set globals to true. Now we can remove the first import statement. Now here we get a bunch of compilation errors from the TypeScript compiler. For example, the TypeScript compiler is complaining that it cannot find the string. To fix this issue, we have to go to our TypeScript configuration file, which is tsconfig.json. Here in the compiler options object, we have a new property called types. We set it to an array, and here we pass vtest/bluemans. Now, the error should appear. Yup, if this doesn't happen on your machine, bring up the command palette and search for TypeScript reload project. Okay? So that was the first improvement. Now the second one. Again, you don't want to import this module in every test file to get access to these custom matches. So let's go to our tests folder. Here we added a file called setup.ts. Now we move this line from our test file into our setup file. Next, we go to our vtest configuration file and reference our setup. So here we set files to test/setup.ts. This setup file is run before each test file. It's useful for configuring our testing environment. Okay. Now, because we have changed our vtest configuration file, we have to go back to the terminal, stop this process, and run our tests in the Right, all our tests are passing great. Now, back to our test file. The last improvement I want to show you here is that you don't have to type import render and screen from testing library every single time. There is a shortcut for this. Here in the extensions panel, search for testing library snippets. We have this extension from TUNG software. Let's install this. Alright, now back to our test file. Instead of manually typing this, we can type ITR and press enter. As simple as that.
Tung 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 sahur.
Okay, here's a great exercise for you to practice what you have learned so far. In our components folder, we have a component called user account. This component has a prop called user of type user. Let's take a look at this type. Here we have three properties, ID, name, and his admin. Now, this component renders the user's name and an edit button if the user is an admin. So I want you to spend 10 to 15 minutes and write all the test cases for this component. To give you a hint, here we need 3 test cases. In one test case, we assert that the user's name is rendered in the DOM. Now, to write this assertion, you cannot use the getByRole method because look, the name is rendered inside a div, and divs don't have a role by default unless we give them a role. But this is unnecessary, so in this test case, you have to use a different query method that is called getByText. Okay? Now, we need 2 test cases for the edit button. In one test case, we pass an admin user to this component and assert that the edit button is rendered. In the other test case, we pass a non-admin user and assert that the edit button is not in the DOM. Now, in this test case, again, you cannot use the getByRole method because getByRole will throw an error if the element you are looking for doesn't exist in the DOM. So, in that test case, you have to use a different method called query_by_role. So we look for a button using this method, and then as part of writing an assertion, you have to use the not property to make sure that that element is not in the DOM. Okay, so spend 10 to 15 minutes on this, and then come back and see my solution. Right, so we go to our test folder. Inside the components folder, we have a new file called user account, the test.txt. First we import screen and render from the testing library. Good. Then we create a test suite called user account. I'm gonna go faster because I'm assuming you have done your exercise, okay? Now here's our first test case. It should render user. Here first we create the user object. We annotate it with its type. Now here we have 2 user types. One is defined in Auth0, the other is defined in the entities module in this project. We're going to pick this one. Now let's create a user object. We set the ID and name to some arbitrary values. Next, we render the user account component and give it this user object. Now our assertion. So here we call screen.getByText and pass user.name. Now this returns an element, but we don't need to store it in a constant because we're going to use it only once. So we can pass it directly to the expect function and assert that this element is in the document. Now look, we have one passing test, great. Now once again, to verify that we're testing the correct behavior, we go to our production code and comment out the line that should make that test pass. So now our test should fail. There you go, we're testing the correct behavior. Now going forward, I'm not going to repeat this over and over because that's repetitive. But I want you to practice this as part of writing your tests, okay? So let's bring this back. We're done with our first test case. Now let's duplicate this and write the test for the edit button. So here we say it should render edit button if user is admin. Here we set is admin to true. Now our assertion is going to be different. So here we call screen.getByRole. We look for a button. We store it in constant because we're going to write to the assertion is this object. First we expect to be in the document, and then we assert that it has the right name. So to have text content, and again here we use a regular expression. That's good. Take a look to passing tests complete. Now the final testing. So let's duplicate this test. First change not render we can set this to false. Now in this test we cannot use getByRole because this will throw an error because we're not going to have a button done. So here we call query by role. We get the button and then expect this button not to be in the document. Okay, let's remove this other assertion. Good. Now take a look. We have 3 passing tests. Well, hello, Mosh here. Thank you for watching my React testing tutorial. I wanted to let you know that this tutorial is the first hour of my complete React testing course. So after you finish this tutorial, if you want to learn more, I highly recommend you to enroll in the free course because it's much faster and easier to learn React testing than jumping over a bunch of disconnected tutorials on YouTube. Everything you need to know is jam-packed in a perfectly structured 7-hour course. We'll cover more advanced topics like mocking APIs, testing forms, testing state management, authentication, and routing. Now, just like my other courses, this course comes with a 30-day money-back guarantee and a certificate of completion. If you're interested, click the link below this video to enroll in the course. Alright, now let's look at an example involving lists. In our components folder, we have a component called userList. This component takes a prop of users, which is an array of users. If the array is empty, it renders no users available. Otherwise, it renders a list of hyperlinks, one for each user. Okay? So let's test this. We go back to our tests folder. In the components folder, we have a new file called userlist.test.txt. Let's do the ceremony. We create a test suite called userlist. And here's our first test case. It should render no users when the users array is empty. And of course, we can word it differently. So here we call render render and give it user list with an empty array. Okay. Now to write our assertion, look, this message is rendered inside a paragraph. Paragraphs don't have a role by default. So once again, we have to use the get by text method. So here we call string text. Now we don't want to look for the exact message like no user is available because this makes our test fragile. If one of the words here changes, our test will break. So we use a regular expression to look for the presence of certain keywords. I think the chances of no user's keyword changing in the future is probably minimal. We're not sure, but I think this makes our assertion a little bit more general and our test will be a little bit more robust. Okay? So we find this element and expect it to be in the document. And by the way, look, when you want to find this method, you don't have to type the whole method name. That's very time consuming. Instead, we can use abbreviations like to be in the document. Okay? So that was our first test. Now take a look. User list. We have one passing test. Great. Now our second test. This test is more interesting. So I'm going to duplicate this test. And here, change the test name to render a list of users. Now, in this test, first we create an array of users. So we annotate this with user array, and again, make sure to pick the type in the entities module.
Brr, patapim, il mio cappello è pieno di slim,
Now,
nel bosco fitto e misterioso.
How can we verify the right item? Here we can iterate over our array of users, and for each user, we look at the link to the users, and then we can verify that link has the right trip. Here's how we do it. So, here we are iterate over this array. For each user, find the link to the user's name. So we call string get variable, we look for link. Now, all these query methods are name for using a text match. We have selected for applying a filter and picking elements that are selected. We also have checked, pressed, and a bunch of other properties. I'm not familiar with all of them, but you will learn about them depending on the types of tests you run. Okay? So here we can pass the options object and apply a filter. We only want to find a link with this name, user.name. Now this returns a link. First we check if link is in the document, and then we check that it has the right href attribute. So we expect link. Now here's another matcher to have attribute. We look for href, and we want this to be like /users. So let's look at our production code. Here's what we expect: /users/user.id. Now I need to clarify something here. In this case, to make it that cheated, we shouldn't write our tests based on our production code, because our production code might have a bug. If we write our assertions based on what we have in the production code, we'll end up with false positives. Our tests will pass, but our application will have a bug. So ideally, we should write our tests based on the requirements. In other words, we should treat each component like a black box. We shouldn't care what's inside, we shouldn't care about the information. We should test what it's supposed to do. Okay? Now, back to our test. So here we'll look for an href like /users/. Now we want to add the ID dynamically, so let's replace this string literal with a template literal. And here we can insert user.id. Take a look, our tests are passing great. Now I want to verify that we're testing the correct behavior. So for the last time, let's comment on this line. Now our test fails. Alright, here's another great exercise for you. In the components folder, we have this component called product image gallery. This component receives a list of image URLs as a string array. Now, if the array is empty, the component renders nothing, otherwise it renders a list of images. So here we need two test cases. In the first test case, we should render this component with an empty array, and then assert that the DOM is empty. Now, we haven't done this so far, so I want you to do a bit of research and solve this problem on your own. It's not complicated. Just search for React Testing Library, assert that the DOM is empty. Now, in the second test case, we should render this component with a list of URLs, and then assert that we have a list of images with the right source attribute rendered in the DOM. Spend 10 minutes on this, then come back and see my solution. Alright, to save your time, I created this test file with the basic setup before recording this video. So here's our first test case. Our component should render nothing if given an empty array. So here we call render and give it product image gallery. Here we set image URLs to an empty array. Now, to assert that the DOM is empty, we get the object that is returned from this function. We can call it result. Now look, result has a bunch of properties. One of them is a container. This is the container for our component. So here we can destructure this object and grab the container. Then we pass it to the expect function. And here we call to be empty DOM element. As simple as that. Now take a look. Our test is passing, great. Now let's work on the second test case. It should render a list of images. Now in this test, first we declare an array of URLs. Let's call it image URLs. We set it to 2 elements, or 1 and 2. Then we render product image gallery. Here we set image URLs to image inputs. Good. Now, in this test, unlike the previous lesson, we cannot iterate over this array, and for each element we assert that we have an element with this URL. Because in the previous lesson we were applying a filter by name, but here we cannot filter elements by their source attribute. So here we have to take a different approach. First we call screen.get all by role. So all query methods that we have seen before, they have a variation for selecting multiple elements. So we have get by role, we also have get all by role, similarly we have get by text, we have get all by text, and so on. So let's call get all by role for selecting multiple images. The role we should pass is img. With this we can get all the images in the DOM. First we should assert that we have 2 images. So we expect images to have length 2. Then for each element in this array, we assert that we have an image with the right source attribute. For example, we can say expect images of 0 to have attribute source, and here we should pass image URLs of 0. And of course we have to repeat this for the second element, but that looks a little bit ugly, so here we can iterate over image URLs using for each. We pass an arrow function here with 2 parameters, URL and index. Now we move this assertion up here and we check that the element at this index have this attribute. That is the URL that we get in this function. Now take a look, our test will pass it. Alright, now let's see how we can test user interactions. Here we have a component called terms and conditions. A very typical implementation where we have our terms and conditions, followed by a checkbox for the user to accept the terms, and a button that is only enabled if the checkbox is checked. Now, before we write tests for this component, let's see it in action. So let's go to this file called playground page. It's inside the pages folder. Now here we're rendering the onboarding component. We don't need it for now. We'll come back to it in the future. So instead, let's render terms and conditions. Now, back to our website. Let's go to the playground page. Here's our component. Now, the button should be initially disabled, but we don't see it visually because I forgot to apply a style here. So, to fix this, let's go to index.css. Here's our button class. Let's add another button class with a disabled selector. Here we set the background to CCC. Now look, our button is initially disabled, but if we check the checkbox, it becomes enabled. This is the behavior we're going to test in this lesson. So, back to our project. Let's go to the tests folder. Here we add a new file called terms and conditions.test.tsx. We do the setup first, then we create a test suite, terms and conditions. Now, in our first test, we want to make sure that our component renders correctly. So nothing new so far, we just want to test the rendering of this component. So here we can say it should render with correct text and initial state. So we call render and pass terms and conditions. Now here we have some basic text. We don't want to look for the presence of this text because this can easily change in the future. The only thing we want to look for in terms of text is our heading. So back to our test. Here we call screen, get by row. Look when I'm typing GBR, that is short for get by row. Okay? So we find the heading. We store it in this object. First, we check that this heading is in the document, so to be in the document. And then we check that it has the right content. To have text content. Now, in this case, we can pass a string. We don't have to use a regular expression because the chances of this heading changing in the future is really minimal. Okay, so that was our text. Now, what about the initial state? Well, we need to verify that we have an unchecked checkbox. So, we call screen, get by row, checkbox, we store it in this object. Now, just like before, we expect checkbox to be in the document. And it should also be unchecked. How do we do that? Well, we have a matcher here called to be checked. Okay? Now we don't have a matcher called to be unchecked, so to verify that our checkbox is unchecked, here we use the not property. Okay? Now, one question I might have here is, isn't that better to split these assertions into two tests? One testing the heading, the other testing the checkbox. We can certainly do that, but in this case, I don't find any value in doing so, because look, we have to repeat this test case 2 more times, and in each test case, we have to render the component. It's a little bit repetitive, so I prefer to have all these assertions regarding rendering in this test case. Like, don't take it as a hard and fast rule. Every problem, every component, every test case is different. So we check the checkbox, and finally we verify that we have the disabled button. So we call screen, get by row, button. Now if we have multiple buttons, here we can apply a filter and look for the button that has, what was the label? That is submit. Okay. So here we can pass a regular expression to filter our buttons. In this case, we don't need that, so let's simplify our test. So we get our button. First we check that the button is in the DOM or in the document. Then we check that our button has the right label to have text content. Submit. And finally, we assert that our button is disabled. So expect button to be disabled. Now, it is possible that in the future, disabled gets changed to something else like continue. So in this case, I prefer to remove this insertion. What we want to focus on is the behavior or the functionality of this component, that the button is only enabled when the checkbox is checked. Testing this behavior is more important and more valuable than testing the content on our web pages. Okay? So that was our first test. Now look, our test is passing, great. So let's see how we can test user interactions. So let's create a second test case. Say, should enable the button when the checkbox is checked. Now, once again, we render our component. Now, to simulate user interactions, we have to use a different library called user event. Back to the documentation testing library. Look, here we have this section called user interactions. We have this
Trallalero tralala, porco Dio e porco Allah.
We have to install this separately to simulate user events. Just note that in React testing library, we also have fire event. A lot of people use this, but it's not the best way to simulate user events because fire event, as explained here, is a lightweight wrapper around the browser's low-level dispatch event API. So it doesn't simulate a real-world scenario, and that is why we have the user event library. The way this library dispatches events is similar to how users use our application, okay? Now, to install this, we have to install testing library / user event as a development dependency. So let's copy this file and paste it in terminal. Good. Back to our test. So first we render our component. Then we look up our checkbox. So screen, then click my role, checkbox. Just like before, we store it here. Now to click this checkbox, first we call user event. This object is defined in testing library / user event. So if your editor doesn't automatically import this, make sure to import it like this.
Tralalero tralala did it.
Back to our test. Here we call user event .setup. This returns an object. We can call it user. Then we call user click checkbox. Now look at the return type of this method. It returns a promise. So here we have to await this and make our test function async. Finally, we make an assertion. So we call screen get by role. We get our button and expect this button to be enabled. Now,
Ballerina cappuccina. Mi 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 mi.
Here we have
È la moglie di cappuccino assassino.
Then we separate the now back in the test UI, most of our tests are passing great. Now we need another test case to assert that our button is disabled if the checkbox is unchecked. I find it quite because our first test case verifies that there is no need to write a separate test case and click the checkbox twice to say here's another fantastic exercise to practice. Look at this component. Text is shorter than 255 characters. It gets rendered. Otherwise, it gets truncated with a ... at the end. And here we have a button for expanding or collapsing the text. Now, before testing this, let's see it in action. So we go to our playground and render our expandable text component. Now let's set the text to a short text. Alright, here's what we get. The full text is rendered, but if we pass a long string here, which we can generate by typing lorem followed by a number, a big number like 100, and tab. That's a long lorem ipsum text. Now we can grab this and paste it here. Look what happens. So our text is truncated, and here we have the show more button. Ignore the styling, I forgot to apply a class. We can fix it by applying the btn class to our button. So here we set class name to btn. Alright, that's better. Now if we click this, we see the full text, and now we have show less. This is a great exercise for you to practice what you have learned so far. So spend 15 to 20 minutes on this, and then come back and see my solution. Alright, just like before, we start with the rendering tests, and then we'll move on to user interactions. So what aspects do we want to test here? For rendering, we want to make sure that if the text is short, the full text is rendered, otherwise our text is truncated. These are the two aspects we need to test. So here's our first test case. Should render the full text if less than 255 characters. So here we call render and pass expandable text. We set the text prop to some short text. Now to look this up in the DOM, use screen.getByText. Now let me show you a shortcut. Earlier in the course, we installed an extension for React testing library. In case you didn't do it, it's right here. Testing library snippets from Beam software. Now with this, we can generate this statement by typing QT, that is query by text. If we press enter, now we have all query methods for looking up an element by text. So we have get by text, get all by text, query by text, and so on. Now, similarly, we have query by role, so QR, but in this case, we're going to go with Qt. Okay? So we're going to look up an element by this text. Now, we don't want to repeat this here. So let's put it in a constant. Short text. And now we can use it in multiple places. Text and text. Now we expect this element to be in the document. Another shortcut, just type tbind. That gives us to be in the document. Okay, let's take a look. Alright, we have one passing test, great. Now, let's write another test case for a long text. So to save time, I'm gonna duplicate this test. Now let's change the test name. Should truncate text if longer than 255 characters. Now to generate a long text, we can grab a character like A and then repeat it, let's say 256 times. Now in this test, we have to look for the truncated text. So let's declare a constant called truncated text. We grab our text, apply a substring, and grab the first 255 characters. And then we append ... at the end. That is what we expect to have in the DOM. So let's pass it to getByText. Take a look. Our test is passing, great. Now, in this scenario, we also want to look for the presence of the Show More button. So to find our button, we type QR, get by role, and pass button. We store it here. First, we expect the button to be in the document, and then we verify that it has the right label. So to have text content, and here we use a regular expression and look for more. Now, earlier I told you that getByRole throws an error if there is no element matching the criteria. So technically speaking, we don't even need to check if the button is in the document, because if it doesn't exist, this test is going to fail on this line anyway. So in this case, we can safely remove this line. But if we didn't have another assertion after, our test would look weird, it would look unfinished. So for clarity, if we don't have other assertions, I would prefer to check if the element is in the document. Okay? We don't need it for now. Now let's take a look. Our test is passing, great. So these are the rendering tests. Now let's test the user interactions. So again, to save time, I'm going to duplicate this test because we're dealing with a long text. Now there are two places where you're generating long text. Let's move these outside of our test cases into a single place. So we can go to our test suite. First of all, we can declare a constant called limit to state 255. So if the requirements change in the future, there's a single place in our tests we need to update. Now for generating a long text, we can grab A and repeat it up to limit plus 1. Now for generating the truncated text, we declare a constant. And here we get our long text and grab the first 255 characters, in this case minute. Okay, now we can simplify our tests a little bit. So we don't need to generate a long text here. Now we need to replace text with long text, and we don't need to compute truncated text either. Okay, so always pay attention to these little details because they will always pay off in the long run. Okay? Now in our last test case, so here we need to change the title to should expand text when show more button is clicked. Again, we don't need to generate a long text here. And similarly for the truncated text. So we find our button, then we need to click it. So here we call user event, that's set up. We get a user object, and then we call user event click button. I told you this returns a promise, so we need to wait it and make our test function async. Alright, so this is the act part. Now we need to separate it from the insertion part. So in this case, we expect the full text to be in the document. So we expect query by text, and here we look for our long text to be in the document. Okay. Also, the label of our button should be changed to show less. Now, as I've said before, there are some folks who are strict about a single insertion in the test, but this is impractical because imagine if we wanted to move this assertion into a separate test. We would have to repeat all this logic in that test. Sure, we can create another test suite and use before each, but all that ceremony is unnecessary. These two assertions are highly related. They're logically part of a particular state of our component. That is why I prefer to put them in the same test. Okay? Let's see if our test passes. Alright, looks like one of our tests failed. I made a mistake. So what's happening here? This is the test for truncating text. The error is saying unable to find the element with the text. Whatever. Okay, so let's take it. So in this test, we are looking for the truncated text. So the test is fine. I probably made a mistake here. Yes, I forgot to add dot at the end. Sorry about that. Alright, now all tests are passing great. There's one more test we need. So we have a test for expanding the text. Now we need a test for collapsing the text. So let's duplicate this test. First, we should change the test name to should collapse text when show less button is clicked.
Patapim, il mio cappello è pieno di slim, nel bosco fitto e misterioso.
Show more button. So I'm going to remove this name here. This is our range button. To expand the text. Now in the add part, we click the button A, and then insert that. The long text is no longer in the document, so we should open truncated text and the show more button. Now take a look. Just passing through, but I don't like the way I'm doing this test. Let me show you a better way. First, we're going to remove this button. this step, we are clicking the Show Less button. Even though it's technically the same button, now our test code better aligns with the test description. This is just a personal preference. You don't have to do this. Now let's see if our tests are still passing. There you go. Beautiful. We're done with this exercise, so let's move on to the next lesson. Okay, let me show you a great technique for simplifying our tests. Let's take a look at the tests we wrote for the terms and conditions component. Now, if you have paid close attention, you have probably noticed that there are a few places where we are looking up our elements. So here we are looking up our checkbox and button, and similarly, in this other test, we are looking up these elements. This is duplication. So let me show you a better way to write these tests. Back to our test suite. Here we define a helper function for rendering our component and returning the common elements we want to query. So we can use the arrow function syntax or function declaration syntax. It doesn't matter. I'm going to go with the arrow function syntax. So we declare a constant called render component. We set it to an arrow function. Now, in this function, we render our component. Then we return an object, and in this object, we add the elements we want to query. So look, in this test, we need the heading, the checkbox, and the button. So here we add three properties: heading, and we set it to screen, get my role, heading. Similarly, we add our checkbox. Let's grab it here. And finally, we add our button. Change it to blue. Now, in this test, instead of calling the render function from React Testing library, we use our own render function, render component. This returns an object, so we destructure it and grab the elements we need: heading, checkbox, and button. Now we can remove these lines. Here's one, here's another one, and one more. Now, earlier I told you that when we use the get by role or any other variations of the get by query method, we don't need to check if the element is in the document, because if not, this line, this statement is going to throw an error. So in this test, we can safely remove this line, and this line, and this line. Now, these three assertions are logically related, so I put them next to each other, because all of them are about checking that our component renders correctly. Okay? Now look, our test is a lot cleaner, it's easier to maintain and understand. Now similarly, in this other test, we call render component. Now here we only need the checkbox and the button. So we can simplify our test, and here we simply pass button to the expect function. That's a lot better. Well, hello, Mosh here. Thank you for watching my React testing tutorial. I wanted to let you know that this tutorial is the first hour of my complete React testing course. So after you finish this tutorial, if you want to learn more, I highly recommend you to enroll in the full course, because it's much faster and easier to learn React testing than jumping over a bunch of disconnected tutorials on YouTube. Everything you need to know is jam-packed in a perfectly structured 7-hour course. We'll cover more advanced topics like mocking APIs, testing forms, testing state management, authentication, and routing. Now, just like my other courses, this course comes with a 30-day money-back guarantee and a certificate of completion. If you're interested, click the link below this video to enroll in the course. JavaScript, the most popular programming language in the world and also one of the most hated languages. But why? Why is there so much JavaScript hate? Let's be honest, JavaScript has baggage. It was created in 1995 by this dude in just 10 days as a tiny scripting language to add a bit of interactivity to web pages. It wasn't meant for the massive, complex apps we build today. So naturally, it's got some weird behaviors that can make everyone, even coding pros, confused. For example, JavaScript automatically converts values from one type to another in operations that involve different types. This is supposed to make JavaScript flexible, but it can lead to some confusion confusing, unpredictable results. For example, if we add two empty arrays, we get an empty string. If we add an empty array to an empty object, we get the string object. But if we swap the order of operands, we get 0. And if we add two empty objects, we get not a number. In JavaScript, we have two operators for comparing values: loose equality or double equals, and strict equality or triple equals. If you accidentally don't type that extra equal sign, you're in for a surprise. Here's another funny example. With double equals, number 0 equals a string 0. Now, number 0 also equals an empty array. So, if number 0 equals empty string and an empty array, we should assume that a string 0 equals an empty array, right? Nope, they're not equal. Here's another funny one. Let's say we have an array of numbers like 1, 100,000, 21, 30, and 4. If we use array.sort to sort this array, we get the same result. Why? Because by default, the sort method sorts elements as if they were strings. To have JavaScript sort numbers correctly, we need to provide a compare function to the sort method. The other issue is that JavaScript has two special values representing no values: null and undefined. A lot of people, especially beginners, don't know the difference, but they are not the same thing. Undefined means a variable has no value assigned, but null means the value is intentionally empty. Another problem is that this keyword, which is supposed to refer to the object that it belongs to, but it can have different values depending on where it's used.
And how the this keyword shifts and morphs, confusing developers as it changes context.
Now, JavaScript pretends to have classes, but it doesn't. JavaScript classes are just syntactic sugar over constructor functions. JavaScript uses prototypical inheritance, which is different from the classical inheritance model we have in languages like Java or C#. The other big problem is the module system in JavaScript. JavaScript was not initially designed for large-scale applications, so it didn't have a native module system like languages like C#, Java, or Python. So over time, people came up with various module systems like CommonJS, AMD, UMD, and finally the official ECMAScript modules. The problem is each of these module systems have their own syntax and conventions, and a lot of older projects still use the older systems. This means we have to translate between module systems using tools like Webpack or Babel, which adds another layer of complexity. Now, TypeScript was created to address these issues. It's a superset of JavaScript that adds static typing and other features. It can help catch errors and make large projects more manageable. But it's a whole other language you can learn on top of JavaScript. Plus, there's an extra build step involved because we have to compile our TypeScript code into regular JavaScript code so browsers can understand. That's why some folks on TypeScript are adding an extra layer of complexity to their projects, so they have been moving away from it. The other problem with JavaScript is its chaotic ecosystem of packages, libraries, frameworks, and even meta frameworks. Every day you see a new Medium or Twitter post about a new JavaScript tool or framework that can do something twice faster and complicating the project tenfold. Junior devs jump up and down on how amazing it is why the project gets more entangled in yet another black box JavaScript. The problem is by the time you learn a new framework, it's already outdated and replaced by something newer and shinier. That's why folks from other backgrounds sometimes get the impression that JavaScript devs spend more time chasing the shiny new tools than practicing core coding principles and best practices. Now, on a positive note, JavaScript runs everywhere. It's the language of web, but also runs on servers. Tons of jobs require JavaScript, so even with all the quirks, it's a language that pays the bills. If you enjoyed this video, give it a like and subscribe for more videos like this. In this video, I'm going to lay out a complete roadmap of the essential skills you need to become a front-end developer. Whether you're a beginner wanting to know what to learn to land a front-end developer job, or someone with some experience looking to level up your skills and filling the gaps, this video is for you. We'll cover what each skill is, why it's important, and a realistic timeline for learning it. Ready? Let's dive in. Web development is generally broken down into two areas: front-end development and back-end development, and then full-stack development, which is a combination of both. Front-end development is all about what the user sees and interacts with. It's the website in your browser or the app on your mobile phone or tablet. Back-end development handles everything behind the scenes, like data processing, storage, and logic. In this video, our focus is only on front-end development. I'm planning to create a similar video on back-end development, so check the description box for the link. Now, before we get started, let's answer a common question. How long does it take to become a front-end developer? Well, the answer varies for everyone, but it can take anywhere from 6 to 12 months of consistent studying and practice. The key here is consistency and continuous learning. To help you on this journey, I've created a free supplementary PDF that breaks down the specific concepts you need to learn for each skill. It also includes several project ideas to help you practice and apply what you have learned. It's a great resource to review your progress, find gaps in your knowledge, and prepare for interviews. You can find the link in the description box. Now let's talk about the essential languages and technologies you need to learn. Front-end development is built on 3 core languages: HTML, CSS, and JavaScript. HTML, or Hypertext Markup Language, is used for structuring web pages. You can define headings, paragraphs, images, links, and more. It's quite simple, and if you dedicate a few hours a day, you can learn the basics in a week or 2. By the way, I have a bunch of tutorials on this channel and complete courses on my website if you're looking for structured learning. Links are in the description box. The next thing you need to learn is CSS, or Stable Style Sheets. CSS is used for styling web pages. It allows us to control colors, fonts, layouts, and so on. It helps create responsive designs that adapt to different screen sizes. With a few hours of practice a day, you can learn the essence of CSS in 2 to 4 weeks. You won't be an expert, but you will have practical knowledge to apply in your projects. As you work on different projects, you will learn additional techniques along the way. The next thing you need to learn is JavaScript, and this is where programming starts. HTML and CSS are for structuring and styling pages, but programming is about logic, it's about algorithms, and this is where JavaScript comes in. With JavaScript, you can make our web pages interactive. You can handle user clicks, validate form data, show pop-ups, get data from the backend, and basically bring our website to life. Now, if you have never programmed before, this might be the most challenging part of your journey because you have to learn how to think like a programmer. It might feel weird at the beginning, but with continuous study and consistent practice, I'm sure you can get a reasonable grasp of it in about 2 months. Again, I have a bunch of tutorials on this channel and complete courses on my website if you prefer structured learning. Links are in the description box. Now, as for code, we need a way to track changes and collaborate with others. That's where version control systems, particularly Git, come into play. Git isn't a programming language. It's a tool that allows us to track changes to our code and revert to previous versions. GitHub, on the other hand, is one of the many platforms that hosts Git repositories, enabling us to share our code with others and work in a team environment. Both Git and GitHub are essential for every developer. Git has a ton of features, but you don't need to know them all for everyday use. Think of it like the 80-20 rule. 80% of the time, you use 20% of Git's features. 1 to 2 weeks of practice is enough to get up and running. The next thing you need to learn is TypeScript. It's a language that's built on top of JavaScript that adds static typing and additional features, allowing us to write more robust code. These days, most companies prefer TypeScript for large-scale applications. So if you want to land a front-end developer job in 2024 and beyond, TypeScript is a must-know. It's relatively small compared to JavaScript, and you can get up and running in about 2 to 3 weeks. Next on our list is a UI, or user interface library or framework. A UI framework is for building user interfaces using reusable components or building blocks. Examples include React, Angular, Vue, and so on. React is the most popular and has a ton of job opportunities. So if you're looking to land a front-end developer job, React is your best bet. Now, to learn React effectively, you need to have a solid understanding of JavaScript and basic grasp of TypeScript, because most React projects these days use TypeScript. So make sure to build a strong foundation in JavaScript before diving into React. Otherwise, you're going to face numerous challenges. With a solid understanding of JavaScript, you can get up and running with React in about 2 months. Then you can explore other options like Angular or Vue to add to your resume. Focus on one framework at a time, learn it properly, do a few projects, and once you have a solid understanding, you can learn other frameworks if you wish. So that's the core of front-end development. These skills are listed on nearly every job description, and with continuous learning and consistent practice, you can learn them all in about 6 months. But I'm going to be honest with you, front-end development is competitive. So to truly stand out, there are additional skills you need to learn to increase your job opportunities. So let's go over them one by one. To learn that with CSS, we can style web pages and make them beautiful. Now, as our projects grow and get more complex, styling compiling pages using plain CSS can help painful and messy. So over time, many solutions have been created to address this problem. One of them is CSS preprocessors, which allow us to write CSS in a more efficient syntax using additional features and then compile it down to plain CSS. Examples include Sass, Less, and Stylus. Different projects use different tools, and you don't need to learn all of these to apply to the front-end developer job. If you're familiar with one of them, you can quickly learn others on the job. Out of these, I would suggest Sass because it's the most popular and a good one to start with. 1 to 2 weeks is enough to get up and running with Sass. Another approach is writing manageable CSS is using the CSS framework. The CSS framework provides free CSS that can be used in our applications. Some of the popular ones are Bootstrap, Tailwind, Foundation, Skeleton, and so on. Now, as you can see here on NPM Trends, Bootstrap used to be very popular and a lot of projects are still using it. But over the past couple of years, Tailwind has been merging and overtaking Bootstrap. So a lot of new projects, particularly React projects, use Tailwind. So out of these, I recommend learning Tailwind. It's not that complicated and you can get a decent grasp of it in about 2 to 4 weeks. Another key skill that employers are looking for, especially in senior developers, is automated testing. With automated testing, we can write code to test our code and make sure it functions correctly. Automated testing minimizes bugs and enhances the overall quality of our applications. There are many testing frameworks out there, but the two most popular ones are Jest and Vitest, which are pretty similar. So once you learn one of them, you can learn the other pretty quickly. Jest is the most popular one, but it has some baggage, so newer projects often use Vitest. Again, they're very similar and you can start with either of them. I believe 3 to 4 weeks is enough to learn the essence of Jest and automated testing principles. Next on our list is Meta Frameworks. A Meta Framework is a higher level framework that sits on top of the core UI library or framework and enhances its capabilities. It's not something that all employees are looking for because it's only used in newer projects. A lot of older projects don't use a Meta Framework, but if you want to have a competitive edge, if you're looking for a better position with a better salary, I would recommend learning a Meta Framework. For React applications, we have Next.js, which is the more popular option, and Rhythmic. I recommend learning Next.js, which you can master in 4 to 6 weeks if you have a strong foundation in React. Now, if you want to get into mobile development and further increase your job opportunities, learn React Native. It's a framework for building cross-platform mobile apps using React. If you have a solid understanding of React, 2 months is enough to get a good grasp of React Native. So that really sums up the essential skills you need to become a front-end developer. If you have any questions, please let me know in the comments below, and I will do my best to answer you right here or in my future videos. If you enjoyed this video, please give it a like and subscribe for more useful content.
Los tun tun tuncitos dicen tun 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 sahur. Tralalero Tralala did it.
Tung 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 sahur. Rescue you and break the chain. Cut to the wicked.
chimpanzinitos dicen, los crocodilitos dicen, los chimpanzinitos dicen, los tung 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 sahur, los tralaleritos dicen tralala, tralala, las vaquitas saturnitas dicen wo, 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 wo. Los crocodilitos dicen kabum, kabum, los trulifulitos dicen bla 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 bla, los chimpancinitos dicen pananiri, pananiri, los borralitos dicen porca, porca, los tuntuncitos dicen tun 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 sahur, los tuntuncitos dicen tun 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 sahur, los liritos dicen la, los capuchinitos dicen assassini, assassini, los patapim dicen patapim, patapim, las capuchinitas dicen capuchina, capuchina, las traleritos dicen tralala, tralala, las tralaleritas dicen tralali, tralali. Your truth will never pass me by. They set their traps, they dig their brr patapim, il mio cappello è pieno di slim, nel bosco fitto e misterioso. TUNG TUNG SAHUR. Tralalero tralala, bombardiro, crocodilo, chimpanzini, bananini, chimpanzini, tung 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 sahur, tralalero tralala, porco dio e porco Allah, tralalero tralala, porco dio e porco Allah, bombardiro, crocodilo, un posturto alligatore, bombardiro, crocodilo, bombardiro, crocodilo, chimpanzini, bananini, bananucci, monkeyucci, chimpanzini, cuccottini, tung 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 sahur, tung 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 sahur, tung 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 sahur. Patapim,
hear your voice.
Tralala,
So strong, I always
tralalero, tralalala. Tralalero, tralalero, tralalala. Bombardiro, crocodilo, crocodilo. Bombardiro, crocodilo,
every breath I take, I give you praise.
cocosini. Bombombini, bombini, cusini. Patapim, tung tung sahur. Cappuccino, frula, pinguino, bla. Vaca Saturnita, ballerina, cappuccina,
Even when the world breaks down, still your mercy's all
Los tralaleritos dicen, los crocodilitos dicen, los chimpancinitos dicen, los tung tung sahur. Los tralaleritos dicen tralala, tralala. Las vaquitas saturnitas dicen wo. Los crocodilitos dicen cabum, cabum. Los trulifulitos dicen bla. Los chimpancinitos dicen bananiri. Los orcaleritos dicen porcala. Los tuntuncitos dicen tung sahur. Los tuntuncitos dicen tung sahur. Los lidilitos dicen la. Los capuchinitos dicen assassini. Los patapim dicen patapim. Las capuchinitas dicen capuchina. Tralaleritos dicen tralala. Las tralaleritas dicen tralali.
fire. You were there with me. Storms were raging, but you set me free. You are my fortress, strong and wide. With you alone, I will not hide. Lift me up when I am low. Your mighty power breaks every foe. You're my rock, my rescue, my safe place. I'm alive, I'm dancing in your grace. Enemies fall, but I still rise. With your light, I touch the sky. You reach down from heaven's throne, pulled me out, called me your own. You trained my hands for battles ahead and filled my heart with love instead.
Scimpanzini, bananini, scimpanzini,
Tung tung
sahur, tralalero, tralala, porco Dio e porco Allah, tralalero, tralala, porco Dio e porco Allah, bombardiro, crocodilo, un fottuto alligatore, bombardiro, crocodilo, scimpanzini, bananini, camalucci, monkey, scimpanzini, cocosini, porco Allah.
Forever you lead me in power and might.
Los tralaleritos dicen tralalala, tralalala. Las vaquitas saturnitas dicen mo, mo, mo. Los rulitos dicen bla, 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 bla. Los chimpancinitos dicen bananini. Los capuchinitos dicen asesini, asesini. Los crocodilitos dicen cabu, cabu. Los lidilitos dicen ladila, ladila. Las capuchinitas dicen capuchina. Las tralaleritas dicen tralalili, tralalili. Las coleguitas dicen amalabu, amalabu. Los parabim dicen parabim, bim, parabim, bim. Los tun tun tuncitos dicen tun 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 sahur. Los tralaleritos dicen, los crocodilitos dicen, los chimpancinitos dicen, los tun 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 sahur. Los tralaleritos dicen tralala, tralala. Las vaquitas saturnitas dicen mo, 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 mo. Los crocodilitos dicen kabum, kabum. Los trulifulitos dicen bla, 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 bla. Los chimpancinitos dicen bananini, bananini. Los orcaleritos dicen orcala. Los tun tun tuncitos dicen tun 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 sahur. Los tun tun tuncitos dicen tun 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 sahur. Los lidilitos dicen larila, larila. Los capuchinitos dicen asesini, asesini. Los patabim dicen patabim, patabim. Las capuchinitas dicen capuchina, capuchina. Tralaleritos dicen tralala, tralala. Las tralaleritas dicen tralali, tralali. Boneka Ambalabu, entitas jahat yang banyak meresahkan masyarakat akhir-akhir ini. Los tralaleritos dicen tralalala, tralalala. Las vaquitas saturnitas dicen mo, mo, mo. Los rulitos dicen bla, 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 bla. Los chimpancinitos dicen pananini. Los capuchinitos dicen asesini, asesini. Los crocodilitos dicen cabum, cabum. Los lidilitos dicen la, la, la. Las capuchinitas dicen capuchina. Las tralaleritas dicen tralalili, tralalili. Las conejitas dicen amalabu, amalabu. Los parapim dicen parapim, parapim. Los tung tung tungcitos dicen tung 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 sahur.
You make me strong. I'll praise you forever with hands held high. For you brought me back and you heard my cry. I cried out to you when I lost my way. You healed my soul and
Tung 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 sahur.
now I sing out loud, bless your holy name. Every beat of my heart will shout.
Los tralaleritos dicen los crocodilitos dicen los chimpancinitos dicen los tung 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 sahur. Los tralaleritos dicen tralala, tralala. Las vaquitas saturnitas dicen mo, 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 mo. Los crocodilitos dicen kabum, kabum. Los rulitos dicen bla, 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 bla. Los chimpancinitos dicen bananini, bananini. Los orcaleritos dicen orcala, orcala. Los tung tung tungcitos dicen tung 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 sahur. Los tung tung tungcitos dicen tung 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 sahur. Los lidilitos dicen la, la. Los capuchinitos dicen asesini, asesini. Los patapim dicen patapim, patapim. Las capuchinitas dicen capuchina, capuchina. Los tralaleritos dicen tralala, tralala. Las tralaleritas dicen tralali, tralali.
Round 4. Fight.
Tralalero, tralala. Bombardiro, crocodilo. Chimpanzini, bananini, chimpanzini. Tung 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 sahur.
Tralalero, tralala. Porcos dio, porcola. Tralalero, tralala. Porcos dio, porcola. Bombardiro, crocodilo. Bombardiro, crocodilo. Chimpancini, bananini, monkey.
But when I spoke, you forgave it all. Lifted my soul, broke down the wall. Now my chains have lost their hold. You restored what guilt had stolen. I'm blessed and free, no more disguise. You see my heart, make it right. Mercy flows, like rivers wide. In your grace
vaquitas saturnitas dicen ho, ho, ho. Los rulitos dicen bla, 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 bla. Los chimpancinitos dicen bananite. Los capuchinitos dicen así, así. Los crocodilitos dicen cabu, cabu. Los liritos dicen la, la, la. Las capuchinitas dicen capuchila. Las tralaleritas dicen tralalí, tralalí. Las pollejitas dicen amadabu, amadabu. Los parabim dicen parabim, bim, parabim, bim. Los tung tung tungcitos dicen tung 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 sahur.
Tung 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 sahur.
Tralaleritos dicen los crocodilitos, dicen los chimpancinitos, dicen los tung 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 sahur. Los tralaleritos dicen tralala, tralala. Las vaquitas saturnitas dicen ho, 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 ho. Los crocodilitos dicen cabu, cabu. Los trulitos dicen bla 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 bla. Los chimpancinitos dicen bananini, bananini. Los orgaleritos dicen orgala. Los tuntuncitos dicen tun 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 sahur. Los tuntuncitos dicen tun 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 sahur. Los lirilitos dicen larila, larila. Los capuchinitos dicen assassini, assassini. Los padabim dicen padabim, padabim. Las capuchinitas dicen capuchina, capuchina. Tralaleritos dicen tralala, tralala. Las tralaleritas dicen tralali. Crocodilo, chimpanzini, bananini, chimpanzini, tung 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 sahur.
Porco Dio,
dicen cappuccina, cappuccina. Tralalitos dicen tralala. Las tralalitas dicen tralali, tralali. Scimpanzini, bananini, scimpanzini, tung 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 sahur, tralero tralala, porco Dio e porco Allah, porco Dio e porco Allah, bombardino, crocodilo, tutto alligatore, bombardino, crocodilo, scimpanzini, bananini, bananucci, monkey, gucci, scimpanzini, crocodili, crocodili, monkey, tung 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 sahur, tung 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 sahur, tung 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 sahur. Cappuccino, assassino, cappuccino, assassino. Patapim, patapim, ballerina cappuccina, ballerina cappuccina. Tralalero tralala, porco Dio e porco Allah. Tralalero tralala, porco Dio e porco Allah.
Ballerina cappuccina. Mi 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 mi. È la moglie di Cappuccino assassino.
Tralalero tralala did it.
Blessed are they who trust His name. His love and mercy never change. Let praise arise forever free for those who trust richly.
È la moglie di Cappuccino assassino e ama la musica la 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 la, la sua passione.
Ground beneath his bed, but I cried out.
porco Dio e porco Allah.
Tra-la-la-la-la, tra-la-la-la, tra-la-la, tra-la-la-la, tra-la-la. Bom bom gorilo, watermelon drilo. Tung 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 sahur, tung tung sahur. Chimpanzini, bononi, chimpanzini, bononini.
Scimpanzini, bananini. Wow, wow.
The truth is
Round 3. Fight.
Tralalero, tralala. Bombardiro, crocodilo. Scimpanzini, bananini. Scimpanzini, tung 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 sahur.
Tralalero, tralala. Porco Dio e porco Allah. Tralalero, tralala. Porco Dio e porco Allah. Bombardiro, crocodilo. Un porco alligatore. Bombardiro, crocodilo. Bombardiro, crocodilo. Scimpanzini, bananini. Bananucci, monkey, rucci, scimpanzini, crocodili. Tung 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 sahur. Tung 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 sahur. Tung 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 sahur.
The mighty one is calling loud.
Patapim, ballerina.
From rising sun to evening cloud.
Tralalero, tralala. Porco Dio e porco Allah. Tralalero, tralala. Porco Dio e porco Allah.
With justice, truth, and light. He doesn't need what we can give. He wants a heart that truly lives.
Tung 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 sahur.
Wants a heart that truly lives. I bring a grateful heart to you. Not empty words, but love that's true. I offer thanks, not just a show. And walk the path you want me to. Scimpanzini, bananini, scimpanzini, tung 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 sahur. Porco Dio e porco Allah. Tralalero, tralala. Porco Dio e porco Allah. Bombardiro, crocodilo, un porco alligatore. Bombardiro, crocodilo, bombardiro, crocodilo. Scimpanzini, bananini, bananucci, monkey, rucci, scimpanzini, crocodili. Tung 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 sahur. Tung 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 sahur. Tung 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 sahur. Your mercy leads, I do your will. Los tralaleritos dicen los crocodilitos, dicen los chimpanzinitos, dicen los tung 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 sahur. Los tralaleritos dicen tralala, tralala. Las vaquitas saturnitas dicen wo 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 wo. Los crocodilitos dicen kabum kabum. Los trulitos dicen bla 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 bla. Los chimpancinitos dicen bananini, bananini. Los orcaleritos dicen orcala. Los tuntuncitos dicen tun 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 sahur. Los tuntuncitos dicen tun 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 sahur. Los bibilitos dicen larila, larila. Los capuchinitos dicen assassini, assassini. Los badabim dicen badabim, badabim. Las capuchinitas dicen capuchina, capuchina. Tralaleritos dicen tralala, tralala. Las tralaleritas dicen tralali, tralali.
You're my shelter, you're my king, you're my refuge. Keeping my spirit safe and warm. Your love is higher than the sky. Your truth will never pass me by. They set their trap, they dig their hole. Though enemies rise with fire and light, I lift my voice and say, my heart is steady, I will sing. You're my shelter, you're my king, you're
Brr patapim, il mio cappello è pieno di slim, nel bosco fitto e misterioso. Patapim, brr patapim.
Your truth will never pass me by.
Tralalero tralala, bombardiro, crocodilo, scimpanzini, bananini, scimpanzini, tung 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 sahur. Tralalero tralala, porco Dio e porco Allah. Tralalero tralala, porco Dio e porco Allah. Bombardiro, crocodilo, un fottuto alligatore. Bombardiro, crocodilo, bombardiro, crocodilo. Scimpanzini, bananini, bananucci, monkey, gucci, scimpanzini, crocodili, crocodili, monkey. Tung 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 sahur. Tung 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 sahur. Tung 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 sahur. Liri li la di la, liri li la di la. Cappuccino assassino, cappuccino assassino. Patapim tim tim, patapim patapim. Ballerina cappuccina, ballerina cappuccina. Tralalero tralala, porco Dio e porco Allah. Tralalero tralala, porco Dio e porco Allah.
No need for disguise. Every breath I take, I give
Tralalero tralala, bombardiro, crocodilo, scimpanzini, bananini, scimpanzini, tung 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 sahur. Tralalero tralala, porco Dio e porco Allah. Tralalero tralala, porco Dio e porco Allah. Bombardiro, crocodilo, un fottuto alligatore. Bombardiro,
With all my heart, from the dark you set me apart. Every word will lift you.
Los tralaleritos dicen tralalala, tralalala. Las vaquitas saturnitas dicen mo, mo, mo. Los rulitos dicen bla, 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 bla. Los chimpancinitos dicen pananini. Los capuchinitos dicen asesini, asesini. Los crocodilitos dicen cabu, cabu. Los lidillitos dicen ladila, ladila. Las capuchinitas dicen capuchina. Las tralaleritas dicen tralalili, tralalili. Las coneguitas dicen amalabu, amalabu. Los parapim dicen parapim bim, parapim bim. Los tun tun tuncitos dicen tun 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 sahur.
Every word will lift you high. You're my joy, my reason why. With all my heart, I sing to you. Forever faithful, forever true.
Tralalero tralala did it.
I'm dancing in your grace. Enemies fall,
tung 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 sahur.
I still rise.
Tung 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 sahur.
I touch the sky.
Los tralaleritos dicen, los crocodilitos dicen, los chimpancinitos dicen, los tun 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 sahur. Los tralaleritos dicen tralala, tralala. Las vaquitas saturnitas dicen mo, 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 mo. Los crocodilitos dicen kabum, kabum. Los rulitos dicen bla, 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 bla. Los chimpancinitos dicen bananini, bananini. Los organelitos dicen organa. Los tun tun tuncitos dicen tun 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 sahur. Los tun tun tuncitos dicen tun 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 sahur. Los lidillitos dicen larila, larila. Los capuchinitos dicen assassini, assassini. Los patapim dicen patapim, patapim. Las capuchinitas dicen capuchina, capuchina. Tralaleritos dicen tralala, tralala. Las tralaleritas dicen tralali, tralali.
I touch the sky. You are faithful to the true and pure.
Bombardiro, crocodilo, chimpanzini, bananini, chimpanzini, tung 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 sahur, tralalero, tralala, porco Dio, porco Allah, tralalero, tralala,
stay, my saving Lord, my only way.
Ballerina cappuccina, mi, è la moglie di Cappuccino Assassino.
Tralalero Tralala did it.
And I rejoice. You lift me up with the gentle voice.
Tralalero tralala, bombardiro crocodilo, scimpanzini, bananini, scimpanzini, tung 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 sahur.
Tralalero tralala, porco Dio e porco Allah. Tralalero tralala, porco Dio e porco Allah. Bombardiro crocodilo, un porco spalligatore. Bombardiro crocodilo, bombardiro crocodilo. Scimpanzini, bananini, bananucci, monkey, scimpanzini, crocodili, crocodili, monkey. Tung 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 sahur, tung 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 sahur, tung 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 sahur. Porco Dio e porco Allah, tralalero tralala, porco Dio e porco Allah.
I was down in the valley.
Boom, 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 bonito, pa, 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 da, pim, tum, 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 sahur. Chimpanzini, bononi, chimpanzini, bononi. They really
porco Dio e porco Allah.
Tra-la-la-la-la, tra-la-lero, tra-la-la, tra-la-lero, tra-la-la. Bom bom bolilo, watermelon drillo. Tung 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 sahur, tung 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 sahur. Chimpanzini, banani, chimpanzini, bananini.
Chimpanzini, bananini. Wow, wow.
You heard my cry. I cried out to you when I lost my way. You healed my soul and made me stay.
Chimpanzini, bananini, bananini. Tung 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 sahur, tung 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 sahur, sahur, tung 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 sahur.
Tralalero tralala did it.
Now I sing out loud, bless your holy name. Every beat of my heart will shout your praise for the rest of my nights and all.
Ballerina cappuccina. Mi 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 mi. È la moglie di Cappuccino Assassino.
Running from the truth, nowhere to hide. But when I spoke, you forgave it all, lifted my soul, broke down the wall. Now my chains have lost their hold. You restored what guilt had stolen. I'm best and free, no more disguise. You see my heart and make it right.
Babylon.